it's actually a big misconception that the Byzantine generals problem was unsolved. So let's say that word solved it. The thing that was unsolved, though, is that all of these solutions assume that you've already agreed on it and fixed the list of who the generals are. And these generals have to be kind of semi-trusted to some extent. They can't just be anonymous people, because if they're anonymous, then like the enemy could just be 99% of the generals. So the in the 1980s and the 1990s, kind of the general use case for distributed system stuff was more kind of enterprisey stuff where you could kind of assume that who the nodes are that are running these kind of computer networks. So if you want to have some kind of decentralized computer network that pretends to be a single computer and that you can kind of do kind of operations on, then it's made out of these kind of 15 specific computers that we know kind of who and where they are, and so we have a good reason to believe that at least 11 of them would be fine.
And it could also be within a single system,
Exactly.
Almost a network of devices, sensors, so on, like in airplanes. I think like flight systems in general still use these kinds of ideas.
Yep. So
that's the 80s.
That's the 80s and 90s. Now, the cypherpunks had a different use case in mind, which is that they wanted to create a fully decentralized global permissionless currency. And the problem here is that they didn't want any authorities, and they didn't even want any kind of privileged list of people. And so now the question is, well, how do you use these techniques to create consensus when you have no way of kind of measuring identities, right? You have no way of kind of determining whether or not some 99% of participants aren't actually all the same guy. And so the clever solution that Satoshi had, this is kind of going back to that presentation I made at DEF CON a few months ago, where I said that the thing Satoshi invented was cryptoeconomics, is this really neat idea that you can use economic resources to kind of limit identity, how many identities you can get. And if there isn't any existing decentralized digital currency, then the only way to do this is with proof of work, right? So with proof of work, the solution is just you publish a solution to a hard mathematical puzzle that takes some clearly calculable amount of computational power to solve.
Welcome, I'm here.
Then you solve 5 of those puzzles, you get 5 identities. And then these are the identities that we run the consensus algorithm.
Yo.
So the proof of work mechanism
Excellent.
described is the
how are you?
idea proposed in the paper that defines Bitcoin. What's the idea of consensus that we wish to reach? Why is consensus important here? What is consensus?
So the goal here, in just simple technical terms, is to basically kind of wire together a set of a large number of computers in such a way that they kind of pretend to the outside world to be a single computer, where that single computer keeps working even if a large portion of the kind of constituents, the computers that make it up break. Right. They kind of break in arbitrary ways. Like they could shut off, they could try to actively break the system, they could do lots of things. So the reason why the cypherpunks wanted to do this is because they wanted to run one particular program on this virtual computer. And the one particular program that they wanted to run is just a currency system, right? It's a system that just processes a series of transactions, and for every transaction, it verifies that the sender has enough coins to pay for the transaction, it verifies that the digital signature is correct, and if the check's passed, then it subtracts the coin one account and adds the coins to the other account, roughly.
So first of all, the proof of work idea is kind of, I mean, at least to me, seems pretty fascinating. I mean, it's kind of a revolutionary idea. Is it obvious to come up with that you can use you can exchange basically computational resources for identity?
It actually has a pretty long history. It was first proposed in a paper by Cynthia Dwork and Vincent Mayor in 1994, I believe. And the original use case was combating email spam. So the idea is that if you send an email, you have to send it with a proof of work attached, and Like, this makes it reasonably cheap to send emails to your friends, but it makes it really expensive to send spam to a million people.
Yeah, it's simple. Really nice. So maybe also taking a step back. So what is the role of blockchain in this? What is blockchain?
Sure. So the blockchain, well, my way of thinking about it is that it is this kind of system where you have this kind of one virtual computer created by a bunch of these nodes in the network. And the reason why the term blockchain is used is because the data structure that these systems use, at least so far, is one where they kind of different nodes in the network periodically publish blocks, and a block is a kind of list of transactions together with a pointer, like a hash of a previous block that it is on top of. And so you have a series of blocks that nodes in the network create, where each block points to the previous block, and so you have this chain of them.
Is the fault tolerance mechanism built into the idea of blockchain, or is there a lot of possibilities of different ways to make sure there's no funny stuff going on?
There are indeed a lot of possibilities. So in a kind of just simple architecture, as I just described, the way the fault tolerance happens is like this, right? So you have a bunch of nodes, and they're just happily and occasionally creating blocks, building on top of each other's blocks. And let's say you have one block, we'll call it kind of block one, and then someone else builds another block, honestly, we'll call it block two. Then we have an attacker. And what the attacker tries to do is the attacker tries to revert block two. And the way they revert block two is, instead of doing the thing they're supposed to do, which is build a block on top of block two, they're going to build another block on top of block one. So you have block one, which has two children, block two, and then block two prime. Now, this might sometimes even happen by random chance. Two nodes in the network just happen to create blocks of time, and they don't hear about each other's things before they create their own. But this also could happen because of an attack. Now, if this happens, you have an attack, then the node in the Bitcoin system, the nodes follow the longest chain. So if this attack had happened, and when the original chain had more than two blocks on it, so for more than two blocks, then everyone would just ignore it, and everyone would just keep following the regular chain. But here, we have block two and we have block two prime, and so the two are kind of even. And then whatever block the next block is created on top of, so say block three is now created on top of block two prime, then everyone agrees that block three is the new head, and block two prime is just kind of forgotten, and then everyone just kind of peacefully builds on top of block three, and the thing continues.
So how difficult is it to mess with the system? So how, if we look at the general problem, what fraction of people who participate in the system have to be bad players?
Okay.
In order to mess with it, is there a good number?
There is. Well, depending on kind of what your model of the participants is and what kind of attack we're talking about, it's anywhere between 23.2 and 50%.
Of what?
Of all of the computing power in the network.
Sorry, so 22 and
23 point, between 23.2 and 50%.
And 50% can be compromised.
So once your portion of the total computing power of the network goes above the 23.2 level, then there's kind of things that you can potentially do, and as your percentage of the network kind of keeps going up, then your ability to do mean things kind of goes higher, and then if you have about 50%, then you can just break everything.
So how hard is it to achieve that level? It seems that so far, historically speaking, it's been exceptionally difficult. So
this is a challenging question. So the economic cost of acquiring that level of stuff from scratch is fairly high. I think it's somewhere in the low billions of dollars.
And when you say that stuff, you mean computational resources?
Yeah, so specifically specialized hardware and ASICs that people use to solve these problems that used to do mining.
Small tangent. So obviously I work a lot in deep learning with GPUs and ASICs for that application. And I tangentially kind of hear that so many of these, sometimes NVIDIA GPUs are sold out because of this other application. And what if you can comment, I don't know if you're familiar or interested in this space, what kind of ASICs, what kind of hardware is generally used these days to do the actual computation for the proof of work?
Sure. So in the case of Bitcoin and Ethereum are a bit different. So in the case of Bitcoin, there's an algorithm called SHA-256. It's just a hash function. And so the puzzle is just coming up with a number where the hash of the number is below some threshold. And so because the hashes are designed to be random, you just have to keep on trying different numbers until one works. And the ASICs are just like specialized circuits that contain circuits for evaluating this hash over and over again, and you have got like millions or billions of these hash evaluators. It's just stacked on top of each other inside of a box, and you just keep on running the box 24/7.
In the ASICs, there's literally specialized hardware designed for this.
Yes.
Oh, it's another tangent. I'll come back to the basics, but does quantum computing throw a wrench into any of this?
A very good question. So quantum computers have two main families of algorithms that are relevant to cryptography. One is Shor's algorithm, and Shor's algorithm is one that completely breaks the hardness of some specific kinds of mathematical problems. So the one that you've probably heard of is it makes it very easy to factor numbers. So figure out what prime factors are that you need to multiply together to get some number, even if that number is extremely big. Shor's algorithm can also be used to break elliptic curve cryptography. It can break any kind of hidden order groups. It breaks a lot of cryptographic nice things that we're used to. But the good news is that for every major use of things that Shor's algorithm breaks, we already know of quantum proof alternatives. Now, we don't use these quantum proof alternatives yet because in many cases they're 5 to 10 times less efficient, but then the crypto industry in general knows that this is coming eventually, and it's ready to take the push to that stuff when we have to. The second algorithm that is relevant to cryptography is Grover's algorithm. And Grover's algorithm might even be a bit more familiar to AI people. It's basically usually described as solving search problems. But the idea here is that if you have a problem of the form, find a number that satisfies some property, then if with a classical computer you need to try n times before you find a number, then with a quantum computer you only need to do square root of n computations. And Grover's could potentially be used for mining, but there's two possibilities here. One is that Grover's could be used for mining, and whoever creates the first working quantum computer that could do Grover's will just mine way faster than everyone else, and we'll see another round of what we saw when ASICs came out, which is that kind of the new hardware just kind of dominated the old stuff, and then eventually it switched to a new equilibrium.
But by the way, way faster, not exponentially faster.
Quadratically faster.
Quadratically faster, which is not sort of, it's not game changing, I would say. It's like ASICs that you said.
Exactly. Yeah, so it would not necessarily break proof of work as of yet.
That's right, yeah.
Now, the other kind of possible world, right, is that quantum computers have a lot of overhead. There's a lot of complexity involved in maintaining quantum states. And there's also, as it became quantum computers actually work with quantum error correction, which requires kind of 1,000 real qubits per logical qubit. And so there's a very real possibility that the overhead of running a quantum computer will be higher than the speed that you get with Grover's, which would be kind of sad, but which would also mean that the given proof of work would just keep working fine.
So the beautiful part. So proof of work is the core idea of Bitcoin. Is there other core ideas before we kind of take a step towards the origin story, the ideas of Ethereum? Is there other stuff that were key to the white paper of Bitcoin?
There's proof of work, and then there's just the cryptography, just kind of public keys and signatures that are used to verify transactions. Those are the big thing.
So then what is the origin story? The human side, but also the technical side of Ethereum.
Sure. So I joined the Bitcoin community in 2011, and I started by just writing. I first wrote for this sort of online thing called Bitcoin Weekly. Then I started writing for Bitcoin Magazine. Um, and
Sorry to interrupt you. This funny kind of story, true or not, is that you were disillusioned by the downsides of centralized control from your experience with World of Warcraft. Is this true, or you're just being witty?
I mean, the event is true. The fact that that's the reason I do decentralization is witty.
Maybe just a small tangent. Have you always had a skepticism of centralized control? Is that
To
sort
some
of
degree, yeah.
has that feeling evolved over time, or has that just always been a core feeling that decentralized control is the future of human society?
It's definitely been felt very attractive to me ever since I could learn that such a thing is possible.
Possible.
Yeah.
So great. So when you joined the Bitcoin community in 2011, you said you began writing. So what's next?
Started writing, moved from high school to university, halfway in between that. I spent a year in university. Then at the end of that year, I dropped out to do Bitcoin things full time. And this was a combination of continuing to write Bitcoin magazine, but also increasingly work on software projects. And I traveled around the world for about 6 months and just going to different Bitcoin communities. Like I went to first in New Hampshire, then Spain, other European places, Israel, then San Francisco. And along the way, I've met a lot of other people that are working on different Bitcoin projects. And when I was in Israel, there were some very smart teams there that were working on ideas that people were starting to kind of call Bitcoin 2.0. So one of these was colored coins, which is basically saying that, hey, let's not just use the blockchain for Bitcoin, but let's also kind of issue other kinds of assets on it. And then there was a protocol called Mastercoin that supported issuing assets, but also supported many other things, like financial contracts, like domain name registration, and a lot of different things together. And I spent some time working with these teams, and I quickly kind of realized that this Mastercoin protocol could be improved by kind of generalizing it more, right? So the analogy I use is that the Mastercoin protocol was like this Swiss Army knife. You have 25 different transaction types for 25 different applications. But what I realized is that you can replace a bunch of them with things that are more general purpose. So one of them was that you could replace like 3 transaction types for 3 types of financial contracts with a generic transaction type for a financial contract that just lets you specify a mathematical formula for kind of how much money each side gets.
By the way, hey, just a small pause. You say financial contract, just the terminology. What is a contract? What's a financial contract?
So this is just generally an agreement where kind of either one or two parties kind of put collateral kind of in, and then they, depending on kind of certain conditions, like this could involve prices of assets, this could involve the actions of the two parties, could involve other things, but they kind of get kind of different amounts of assets out that just depend on things that happen.
So a contract is really financial contract is at the core. It's the core interactive element of the financial system.
Yeah, there's many different kinds of financial contracts. Like there's options where you give someone the right to buy a thing that you have for some specific price for some period of time. There's contracts for difference where you basically are kind of making a bet that says like, for every dollar this thing goes up, I'll give you $7, or for every dollar the thing goes down, you give me $7, or something like that. And
But the main idea that these contracts have to be enforced and trusted is
yes, exactly.
you have to trust that they will work out in the system where nobody can be trusted.
Yes.
This is such a beautiful, complicated system. Okay, so you were seeking to kind of generalize this basic framework of contracts.
Mm-hmm.
So what does that entail? What technically are the steps to creating Ethereum?
Sure. So I guess just to kind of continue a bit with this Mastercoin story.
Sure.
So started by giving ideas for how to generalize the thing, and eventually this turned into a much more kind of fully fledged proposal that just says, hey, how about you scrap all your features and instead you just uh, put in this programming language. And I gave this idea to them, and their response was something like, hey, this is great, but this seems complicated and it seems like something that we're not going to be able to put onto our roadmap for a while. And my response to this was like, wait, do you not realize how revolutionary this is? Well, I'll just go do it myself. And then
What was the name of the program?
I just called it ultimate scripting. So then I went through a couple more rounds of iteration, and then the idea for Ethereum itself started to form. And the idea here is that you just have a blockchain where the core unit of the thing is what we call contracts. It's these kind of accounts that can hold assets and they have their own internal memory, but that are controlled by a piece of code. And so if I send some ether to a contract, the only thing that can determine where that ether, the currency inside Ethereum goes after that is the code of that contract itself. And so basically kind of sending assets to computer programs becomes this kind of paradigm for creating these sort of self-executing agreements.
Self-executing. That's so cool that code is sort of part of this. So that's what's meant by smart contracts.
Yeah.
So how hard was it to build this kind of thing?
Harder than expected. And originally, I actually thought that this would be a thing that I would kind of casually work on for a couple of months, publish, and then go back to university.
Mm-hmm.
Then I released it, and a bunch of people, or I released the white paper.
The white paper, the idea
Yeah.
is there.
The idea, the white paper. A whole bunch of people came in offering to help. A huge number of people had expressed interest, and this was something I was totally not expecting. And then I realized that this would be something that's kind of much bigger than I had ever thought that it would be. And then we started on this kind of much longer development slog of making something that lives up to this at a much higher level of expectations.
What are some of the? Is it fundamentally like software engineering challenges?
It
Is there
was
social? Okay, so there's
and social.
so what are the biggest interesting challenges that you've learned about human civilization and software engineering through this process?
So I guess one of the challenges for me is that like I'm one of the kind of apparently unusual geeks who was kind of never treated with anything but kindness at school.
Yeah.
And so when I got into crypto, I kind of expected everyone would just kind of be the same, kind of altruistic and nice in that same way. But the algorithm that I used for finding co-founders for this thing was not very good. It was sort of literally what computer scientists call the greedy algorithm. Instead of the first 15 people who replied back offering to help kind of are the co-founders.
What do you mean, like literally the people that will form to be the founders, co-founders of the community? The algorithm, I like how you call it the algorithm.
Yeah, and so what happened was that these, like especially as the project got really big, like there started to be a lot of this kind of infighting, and there are a lot of like I wanted the thing to be a nonprofit, and some of them wanted to be a for-profit, and then there started to be people who were just kind of totally unable to work with each other. There were people that were kind of trying to get an advantage for themselves in a lot of different ways, and this just about 6 months later led to this big governance crisis, and then we kind of reshuffled leadership a bit, and then the project kept on going. Then 9 months later, there was another governance crisis, and then there was a third governance crisis. And so,
is there a way to, if you look at the human side of things, is there a way to optimize this aspect of the cryptocurrency world? It seems that there is, from my perspective, there's a lot of different characters, personalities, egos. Like you said, I don't know. I also like to think that most of the people in the world are well intentioned, but the way those intentions are realized may perhaps come off as
Yeah.
as negative. Like, what is there a hopeful message here about creating a governance structure for cryptocurrency that where everyone gets along?
And after about 4 rounds of reshuffling, I think we've actually come up with something that seems to be pretty stable and happy. I think, I mean, I definitely do think that most people are well intentioned. I just think that like one of the reasons why I like decentralization is just because there's like this thing about power where power attracts people with egos, and so that just allows a very small percentage of people to use to ruin so many things.
You think ego has a use? Like, is ego always bad? It seems like
It
some of
sometimes
us.
does. Within the theory research team, I feel like we've found also in a lot of very good people that are just primarily just interested in things on the technology, and things seem to be generally be going quite well.
Yeah, when the focus and the passion is in the tech. So that's the human side of things. The technology side, like what have you learned? What have been the biggest challenges to bringing Ethereum to life on the technology side?
So I think first of all, just there's like the first law of software development, which is that when someone gives you a timetable on a solution time to the next largest period of time in that one, and we basically fell victim to that. And so instead of taking like 3 months, it ended up taking like 20 months to launch the thing. And that was just, I think, underestimating the sheer technical complexity of the thing. There were research challenges, like so. For example, one of the things that we've been saying from the start that we would do, one is a switch from proof of work to a proof of stake. Where proof of stake is this alternative consensus mechanism where instead of having to waste a lot of computing power on solving these mathematical puzzles that don't mean anything, you kind of prove that you have access to coins inside of the system, and this kind of gives you some level of participation in the consensus.
Can you maybe elaborate on that a little bit? I understand the idea of proof of work. I know that a lot of people say that the idea, you maybe link on it longer, explain what it is.
Sure. So basically, the idea is like if I kind of lock up 100 coins, then I turn that into a kind of quote virtual miner, and the system itself kind of automatically randomly assigns that in a virtual miner the right to create blocks at particular intervals. And then if someone else has 200 coins and they unlock those 200 coins, then you get a kind of twice as big virtual miner, and they'll be able to create blocks twice as often. And so it tries to do similar things to proof of work, except instead of the thing kind of rate limiting your participation being your ability to crank out solutions to hash challenges, the thing that really limits your participation is kind of how much points you're locking into this mechanism.
Okay, so interesting. So that limited participation doesn't require you to run a lot of compute.
Mm-hmm.
Does that mean that the richer you are, so rich people are more, like their identity is more
Right, and that's
stable,
yeah,
verifiable, or whatever the right terminology is.
right, and this is definitely a common critique. I think my usual answer to this is that like proof of work is even more of that kind of system.
Yes, exactly.
Yeah,
I didn't mean it as a criticism. I think you're exactly right. That's equivalent. That proof of work is the same kind of thing, but in the proof of work you have to also use physical resources.
yes, and burn computers and burn trees and all of that stuff.
Is there a way to mess with the system of proof of stake?
There is, but you will once again need to have a very large portion of all the coins that are locked in the system to do anything bad.
Got it. Yeah, just that take a small tangent. One of the criticisms of cryptocurrency is the fact, I guess, for the proof of work mechanism, you have to use so much energy in the world.
Yes.
Is one of the motivations of proof of stake is to move away from this?
Definitely.
Like, what's your sense of it? Maybe I'm just underinformed. is there like legitimately environmental impact from this?
Yeah, so the latest thing was that Bitcoin consumed as much energy as the country of Austria or something like that. Yeah, and then Ethereum is like right now maybe only like half an order of magnitude smaller than Bitcoin.
I've heard you talk about Ethereum 2.0. So what's the dream of Ethereum 2.0? What's the status of proof of stake as a mechanism that Ethereum moves towards? And also, how do you move to a different mechanism of consensus
Sure.
within a cryptocurrency?
So Ethereum 2.0 is a collection of major upgrades that we've wanted to do to Ethereum for quite some time. The two big ones, one is proof of stake, and the other is what we call sharding. Sharding solves another problem with blockchains, which is scalability. And what sharding does is it basically says instead of every participant in the network having to personally download and verify every transaction, every participant in the network only downloads and verifies a small portion of transactions. And then you kind of randomly distribute who gets how much work. And because of how the distribution is random, it still has the property that you need a large portion of the entire network to corrupt what's going on inside of any shard, but the system is still very redundant and very secure.
How hard is that to implement, and how hard is proof of stake to implement? Like on a technical level,
Yeah,
software level.
proof of stake and sharding are both challenging. I'd say sharding is a bit more challenging. The reason is that proof of stake is going to have just a change to how the consensus layer works. Sharding does both that, but it's also a change to the networking layer. The reason is that sharding is kind of pointless if at the networking layer you still do what you do today, which is you kind of gossip everything, which means that if someone publishes something, every other node in the client hears it on the networking layer. And so instead, we have to have kind of sub-networks and the ability to quickly switch between sub-networks and other sub-networks talk to each other. And this is all doable, but it's a more complex architecture, and it's definitely the sort of thing that has not yet been done in cryptocurrency.
So most of the networking layer in cryptocurrency is you're shouting, you're like broadcasting messages, and this is more like ad hoc networks. Like
You're shouting with smaller groups.
Smaller group, but you have like a bunch of subnet, like
Exactly.
You have to switch between. Oh man, I'd love to see that. So it's a beautiful idea from a graph user perspective, but just the software that, and who's responsible? Is the Ethereum project that people involved? Would they be implemented? Like, what's the actual? This is like legit software engineering. How does that work? How do people collaborate, build that kind of project? Is this like almost is there a software engineering lead? Is there? Is it a legit, almost like large scale open source project?
There is, yeah. So we have someone named Danny Ryan on our team who's just been brilliant and great all around. And he is a kind of de facto kind of development coordinator, I guess. It's like you have to invent job titles for this stuff. Right? The reason is that we also have this unique kind of organizational structure where the Ethereum Foundation itself kind of does research in-house, but then the actual implementation is done by independent teams that are separate companies, and they're located all around the world in like fun places like Australia. And so you kind of just need a bunch of kind of almost nonstop cat herding to just keep getting these people to kind of talk to each other and kind of implement this back, make sure that everyone agrees on kind of what's going on and kind of how to interpret different things.
So how far into the future are we from these two mechanisms in Ethereum 2.0? Like, what's your sense of the timeline, keeping in mind the previous comments you made about the sort of general curse of software projects?
So Ethereum 2.0 is split into three phases. So phase 0 just creates the proof of stake network, and it's actually separate from the proof of work network at the beginning, just to give it time to grow and improve itself.
Do people get to choose? Sorry, do people get to choose? I guess.
They get to choose to move over if they want to. Then phase 1 adds sharding, but it only adds sharding of data storage and not sharding of computation. And then after that, there is the merger phase, which is where the and if the accounts and the smart contracts, like all of the activity in the existing E1 system, just kind of gets cut and pasted into E2, and then the proof of work chain gets forgotten, and the things, all of the things that were living there before, just kind of continue living inside of the proof of stake system. So for timelines, phase 0 has been kind of almost fully implemented, and now it's just a matter of a whole bunch of security auditing and testing. My own experience is that right now it feels like we're at about a phase comparable to when we were doing the original Ethereum launch, when we were maybe about 4 months away from launch.
So that's just a hunch thing.
That's just a hunch, yeah.
So how, it took like over a decade for people to move from Python 2 to Python 3. How do you see the move from like at this phase 0 for different consensus mechanisms? Do you see there being a drastic phase shift and people just kind of jumping to this better mechanism?
So in phase 0, I don't expect too many people to do much, because in phase 0 and phase 1, the new chain, again, it's deliberately it doesn't have too much functionality turned on. It's there just like if you want to be a proof of stake validator, you can get things started. If you want to store data for other blockchain applications, you can get started. When existing applications will largely keep living on ETH1. And then when the merger happens, then the merger is a operation that happens all at once. Right? So that's kind of one of the benefits of a consensus system, that like on the one hand you have to coordinate the upgrade, but on the other hand the upgrade can be coordinated.
So what's Casper FFG, by the way?
Casper FFG is the consensus algorithm that we are using for the proof of stake.
Is there something interesting specific about Casper FFG, like some beautiful aspect of it that's
there he is. So Casper FFG combines together kind of two different schools of consensus algorithm design. So the general two different schools of this design are, right? One is 50% fault tolerant, but dependent on network synchrony. So 50% fault tolerant, but it can tolerate up to 50% of faults, but not more. But it depends on an assumption that all of the nodes can talk to each other within some limited period of time. Like if I send a message, you'll receive it within a few seconds. And the second school is 33% fault tolerant, but safe under asynchrony, which means that if we agree on something, then that thing is finalized, and even if the network goes horribly wonky a second after that thing is finalized, there's no way to revert that thing. And
it's fascinating how you would make that happen.
It's definitely quite clever. I'd recommend the Casper FFG paper. If you just search like archive as in like ARXIV Casper FFG,
that's an archive. The paper is an archive.
Yeah.
Or the office.
Myself and Virgil Griffith.
That's awesome. I take a small tangent. This idea of just putting out white papers and papers and putting them in an archive, just putting them publicly, is that at the core? Is that a necessary component of cryptocurrency? Is that the tradition started with Satoshi Nakamoto? What do you make of it? What do you make of the future of that kind of sharing of ideas?
I guess so, yeah. It's definitely something that's kind of mandatory for crypto, because crypto is all about making systems where you don't have to trust the operators to trust that the thing works. And so if anything behind how a system works is closed source, then that kind of kills the point. And so there is the kind of a sense in which the fundamental properties of the category of the thing we're trying to build just kind of forces openness. But also openness just has proven to be a really great way to collaborate. And there's actually been a lot of innovation and academic collaboration that's just kind of happened ad hoc in the crypto space the last few years. So like, for example, we have this forum called ETH Research, that's like ETHRESEAR and then .ch. And there we publish just ideas in a form that's kind of half formal, like it's halfway in between, like it's a kind of a text write-up, and then you can have math in it, but it's often in a much shorter than a paper. And like, it turns out that the great majority of new ideas, like they're just kind of fairly small nuggets that you can explain in like 5 to 10 lines, that they don't really
They don't need the full formality of a paper, right?
exactly they don't require the kind of like 10 pages of a filler, and so
Introduction, conclusion is not needed.
yeah, and so instead you just kind of publish the idea, then people can go comment on it, and yeah, that's really great for us.
I think I interrupted you. Was there something else like Casper FFG?
No, so just Casper FFG is just kind of combines together these two schools, and so basically it creates this system where if you have more than 50% that are honest, then and you have network synchrony, then the thing kind of goes as a chain. But then if network synchrony fails, then kind of the last few blocks in the chain might kind of get replaced. But anything that was finalized by this kind of more asynchronous process gets can't be reverted. And so you essentially get a kind of best of between those two models.
Okay, so I know what I'm doing tonight. I'm going to be reading the Casper FFG paper. Apologize for the romanticized question, but what to you are some or the most beautiful idea in the world in this area? Just something surprising, something beautiful, something powerful.
Yeah, and I think the fact that money could just emerge out of a database if enough people believe in it, I think is definitely one of those things that's up there. I think one of the things that I really love about Ethereum is also this concept of composability. So this is the idea that like, if I build an application on top of Ethereum, then you can build an application that talks to my application, and you don't even need my permission. You don't even need to talk to me. But, so one really fun example of this is there was this kind of game on Ethereum called Crypto Kitties that just involved kind of breeding digital cats.
Yeah.
And someone else created a game called Crypto Dragons, where the way you play Crypto Dragons is you have a dragon and you have to feed it Crypto Kitties. And they just created the whole thing just like as an Ethereum contract that you would send these tokens that are defined by this other Ethereum contract. And for the interoperability to happen, like the projects don't really need to, like the teams don't really need to talk to each other. You just kind of interface with the existing program.
It's just arbitrarily composable in this kind of way. So you have different different groups that you look at. So you can see it scale it just outside of dragons and kitties. It could be built like entire ecosystems of software.
Yeah, I mean, especially in the decentralized finance space that's been popping up the last 2 years, there's been a huge amount of really interesting things happen as a result of this.
Is it a particular kind of like financial applications kind of thing?
Yeah, I mean, there's like stable coins, so this is kind of tokens that retain value equal to $1, but they're kind of backed by cryptocurrency. Then there's decentralized exchanges. But as far as the decentralized exchanges goes, there's this really interesting construction that has existed for about 1.5 years now called Uniswap. So what Uniswap is, it's a smart contract that holds the balances of two tokens. We'll call them token A and token B. And it maintains an invariant that the balance of token A multiplied by the balance of token B has to equal the same value. And so the way that you trade against the thing is basically like you have this kind of curve, you know, like x times y equals k, and before you trade, it's at some points on the curve. After you trade, just like pick any other points on the curve, and then whatever the delta x is, that's the amount of A tokens you provide. Whatever the delta y is, that's the amount of B tokens you get, or vice versa. And that's just, and then kind of the slope in at the current points on the curve kind of is the price. And so that just is the whole thing. And that just allows you to have this exchange for tokens, and even if there's very few participants, and the whole thing is just like so simple, and it's just very easy to set up, very easy to participate in, and it just provides so much value to people. So,
and the fundamental, the distributed application infrastructure allows that somehow.
Yes. So this is a smart contract, meaning this is all a computer program that's just running on Ethereum.
Smart contracts too are just fascinating.
They are.
Okay, do you think cryptocurrency may become the main currency in the world one day? So where do you think we're headed in terms of the role of currency, the structure and type of currency in the world?
And I definitely expect fiat currencies to continue to exist and continue to be strong, and I definitely expect that fiat currencies to also digitize in their own way over the next couple of decades.
What's fiat currency, by the way?
Oh, just like things like US dollars and like dollars and euros and yen and these other things.
And they're sort of backed by governments.
Yes. But I also expect cryptocurrencies to play this kind of important role in just making sure that people always have an alternative if fiat currencies start breaking. So, like if you're in some very high inflation place like Venezuela, for example, or if your country just kind of gets cut off from cut off from other financial systems because of something the banks do. Like if there's even like some major trade disruption or something worse happens, then like cryptocurrencies are the sort of thing that just because of their kind of global neutrality, they've just been always there and you can keep using them.
It's interesting that you're quite humble about the possibilities of the future of cryptocurrency. You don't think there's a possible future where it becomes the main currency? Because it feels like the centralized control by governments of currencies limiting somehow. Maybe in my naive utopian view of the world.
It's definitely very possible. I mean, I think like for cryptocurrencies being the main form of value to well, like you do need to have some much more price stability than they have today. And I mean, there are now stable coins, and there are kind of cryptocurrencies that try to be more stable than the existing things like Bitcoin and Ether. But that just is, to me, kind of the main challenge.
Do you think that's a characteristic of this just being the early days? It's such a young concept. The 10 years is nothing in the history of money.
Yeah, I think it's a combination of two things, right? One is that it's still early days, but the other is a kind of more durable any kind of economic problem, which is that like demand for currency is volatile, right? Because of like recessions, booms, changes to technology, lots of things, and if people's demand for how much currency they want to hold changes. And if you have a currency that has a fixed supply, then the change in demand has to be entirely expressed as a change in value of the currency. And so what that means is that kind of the volatility of demand becomes entirely translated into volatility and kind of prices and fixed denominated in that currency. But if you have a currency where instead the supply can change, and so the supply can kind of go up when there's more demand, then you have the supply kind of absorbing more of that volatility, and so the price of the currency would absorb less of the volatility.
On that topic, so Bitcoin does have a limited supply.
Yeah.
What's the idea? And the Ethereum doesn't. But can you clarify? Just on the comment you just made, is Ethereum qualify to the kind of currency that you're talking about and being flexible in the supply?
I mean, it's a bit more flexible, but kind of the thing that you would really want is something that's kind of specifically flexible in response to how valuable the currency is. And I'd recommend to look at stable coins as well. So like DAI, for example, that's like
How do you spell that?
DAI.
And what's stable coins? Is it a type of cryptocurrency?
It is a type of cryptocurrency. It's a type of cryptocurrency that's issued by a smart contract, one of these Ethereum computer programs, that where the smart contract holds a bunch of Ether, and then it basically like that people deposit, and then it issues DAI, and the reason why people deposit is because they want to kind of go high leverage on their Ether. So it kind of pairs these two sets of users, one that wants stability and one that kind of wants extra risk together with each other. And it basically creates or gives one set of participants a guarantee that they'll be that they have this asset that can be later converted back into ether, but they specifically advocate it's a $1 rate.
It has some kind of stabilizing work effects.
It has many kinds of stabilizing mechanisms in it.
That's fascinating. Okay, this world is awesome technically. Just from a scientific perspective, it's an awesome world. That I often don't see from an outsider's perspective. What I often see is kind of maybe hype and a little bit, if I may say so, like charlatanism.
Mhm.
And you don't often see, at least from my outsider's perspective, the beautiful science of it, the engineering of it. Maybe is there a comment you can make of how to follow, how to learn about this world without being interrupted by the charlatans and the hype people in this space?
I think you do need to just know the specific just people to follow. Like there's all the kind of the cryptographers and the researchers, and there's just like even just the Ethereum research crew, like myself, Dan Grant, Danny, Justin, the other people, and then the academic crews. Like before this today, I was at Stanford, and Stanford has the Center for Blockchain Research, and Dan Bonnet, this really famous and great cryptographer, was running it, and there's a lot of other people there, and there's people working on zero knowledge proofs, for example, and Zuko from Zcash is one other person that I respect. So I think if you follow the technical,
Just crawl along that.
you just
start with the Ethereum group and then look at the academics, and so on, and then just cautiously expand the network of people you follow.
Yeah, exactly. And like if someone seems too self-promotional, then just remove them.
Is there books that are there's these white papers we just discussed about ideas being condensed into really small parts. Is there books that are emerging that are kind of good introductory material?
So for historical ones, and there's like Daniel Popper's Digital Gold, which is just about the history of Bitcoin. There's one, like Matthew Leising announced that there's one about the history of Ethereum. For technical ones, like there's Andreas Antonopoulos' Mastering Ethereum.
Great. So let me ask you to pull back to the idea of government and decentralized currency. There's a tension between decentralization of currency and the power of nations, the power of governments. What's your sense about that tension? Is there some room for regulation of currency? Is government the enemy of digital currency, of distributed currency, or can they be like cautious friends?
I mean, I think like the one thing that people forget is that it's clearly not entirely an enemy, because I think that if there hadn't been so much government regulation on centralized issuing centralized digital currency, instead of we'd be seeing things that people like Google and Facebook and Twitter just issuing them left and right, and that if that was the case, then decentralized currencies would still appeal to some people, but they definitely would appeal to less people than today. So even in that sense, I think it's really clearly been more of a help, just kind of set the stage for the existence of the sector in some ways, but also, and I think some of both. There's definitely things that governments kind of can do, in some cases have done to hurt the spread of and the growth of blockchains. There's things that they've done to help, and they've in some cases definitely done a good job of going after fraudulent projects, and they're going after some of the projects that have some of the craziest and most misleading marketing. There's also the possibility that governments will end up using blockchains for a lot of different things. The governments, they do a lot more than just regulating, right? But there's also they have identity records, they have property registries, even their own currencies, security, lots of different kind of things that they're operating, and there's even blockchain application in a lot of this.
And they can leverage technology to a lot of good for our societies.
Mhm.
It is a little unfortunate that governments often lag behind in terms of their acceptance and leverage of technology. If you look at the autonomous vehicle space, the AI in general, they're a few years behind. It'd be nice to help them catch up. That's the always ongoing problem. You met Vladimir Putin to discuss centralized currency. You're born in where were you born?
Kolomna, it's a city about 115 kilometers south of Moscow.
In Russia.
Yes.
Yeah, I grew up in Moscow. That's Vladimir Putin is a central figure in this part of the world. So what was that like meeting him? What was that experience like?
He's taller in photos than in person.
Yeah, yeah, that's right. He's 5'7", I think, 5'8", maybe.
Yeah, that's unfortunately I didn't actually kind of have too much of a chance to talk to him. Like I managed to see him for about 1 minute at the end of this meeting. And I did get a chance to see a lot of some of the other government ministers that he recommended some. And some of them are actually interested in trying to use some blockchains to for various government use cases, limit corruption and other things. And I have it's hard to tell from one conversation kind of what things are genuine and what things are just like, oh, blockchain is cool, let's do blockchain.
Right. Mm-hmm. But when I listen to like Barack Obama talk about artificial intelligence, there's certain things I hear where, okay, so he might not be an expert in AI, but he like actually studied it carefully enough to think about it. Like he even if it's just reading a Wikipedia page, like he really thought about what this technology needs. Did you get a sense that Putin or some ministers like thought about blockchain, like thought about the fundamentals of technology, or like understand it intuitively, or are they too old school to try to grasp it?
Some are old school, some are more new school. It depends. It's definitely it depends on who you talk to.
I mean, that's an open question for me with Putin because Putin has said
I don't know. I only talked to him for about 1 minute, so
sometimes you can pick up sort of insights. As a quick comment, they're about, maybe you can correct me on this, but there are about 3,000 cryptocurrencies being actively traded.
Yes.
And Ethereum is one of, a lot of people believe that there will be the main cryptocurrency. I think Bitcoin is probably still the main cryptocurrency, but Ethereum very likely might become the main one. Is this kind of diversity good in the crypto world? Do you see it sticking around? Should there be a winner? Like, should there be some consensus globally around Bitcoin or around Ethereum? Like, what's your sense?
I definitely think the diversity is good, and I definitely think also that there's probably too many people trying to make separate blockchains right now. I mean, the number should definitely be greater than 1, and probably greater than 2 or even 5.
Not 3,000.
Not 3,000, yeah, and also not even like 40 high quality platforms that try to do the same thing. Yeah, there's definitely this range from just like one person who just like wrongly thinks that you can create a cryptocurrency in like 12 hours and doesn't even think about the community aspects of maintaining it, going to people actually trying but only creating real one, to scammers, to people making something that's successful, and then there's a lot of different categories of blockchain of project in terms of what it's trying to do and what applications it's for. And I think the experimentation is definitely healthy.
If you look at the two worlds, that might be a little bit disjoint, but the distributed applications, cryptocurrency, and then the world of artificial intelligence. Mm-hmm. Do you see there's some overlap between the worlds that both worry about centralized control? Is there some overlap that's interesting when you think about AI much?
Yeah, and I think definitely in the thought about things like in like the AI and the control problems and alignment problems and all of those things.
Do you worry about the existential threat of AI?
It's definitely one of the things I worry about. I think block, there's a lot of kind of common challenges because in both cases, what you're ultimately trying to do is you're trying to kind of get a simple system to direct a more complex system. Like in the case of this strong AIs, the idea would be that the simple system is people and the complex system is well, whatever thing the people end up kind of unleashing on the universe. That'll hopefully be a great thing. And in the case of blockchains, the complex well, the thing is the algorithm, which is a piece of static and fully open source code, and the more complex thing is just all of the different possible kind of human actors and the strategies that they might end up used to participate in the network.
Do you think about your own mortality? Like what you hope to accomplish in your life?
I definitely think about ending my own mortality.
So that's, if I gave you the option to live forever, would you?
Depends a lot on what the fine print is. If it's one of those things where I'm going to be kind of like floating through empty space for 10 to the 75 years, then no. If it's forever worth of and having, a fulfilling life with and meaning with friends to spend the time with kind of meaningful challenges to explore and interesting things to be working on, then I think absolutely.
That's beautiful. But live forever, but you have to check the fine print. I think there's no better way to end it. Natalia, thank you so much for talking to us. It's so exciting to follow your work from a distance, and thank you for creating a revolutionary idea and sticking with it and building it out. Doing some incredible engineering work. Thanks for talking today.
Yeah, thank you.
Thanks for listening to this conversation with Natalia Buterin. And thank you to our sponsors, ExpressVPN Masterclass. Please consider supporting the podcast by signing up to masterclass.com/Lex and getting VPN at expressvpn.com/LexPod. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars, support it on Patreon, or simply connect with me on Twitter at Lex Free. Now, let me use the words of Natalia Buterin. The thing that I often ask startups on top of Ethereum is, can you please tell me the Ethereum blockchain is better than using it itself? And if they can come up with a good answer, that's when you know that's something really interesting. Thank you for listening. Hope to see you next time. The following is a conversation with Anka Dragan, a professor at Berkeley working on human-robot interaction, algorithms that look beyond the robot's function in isolation and generate robot behavior that accounts for interaction and coordination with human beings. She also consults at Waymo, the autonomous vehicle company, but in this conversation, she's 100% wearing her Berkeley hat. She is one of the most brilliant and fun roboticists in the world to talk with. I had a tough and crazy day leading up to this conversation, so I was a bit tired, even more so than usual. But almost immediately, her energy, passion, and excitement for human-robot interaction was contagious. So I had a lot of fun and really enjoyed this conversation. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, or simply connect with me on Twitter at Lex Friedman, spelled Fridman. As usual, I'll do 1 or 2 minutes of ads now, and never any ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. When you get it, use code LEXPODCAST. Cash App lets you send money to friends, buy Bitcoin, and invest in the stock market with as little as $1. Since Cash App is fractional share trading, let me mention that the order execution algorithm that works behind the scenes to create the abstraction of fractional orders is an algorithmic marvel. So big props to the Cash App engineers for solving a hard problem that in the end provides an easy interface that takes a step up to the next layer of abstraction of the stock market, making trading more accessible for investors and diversification much easier. So again, if you get Cash App from the App Store or Google Play and use the code LEXPODCAST, you get $10. Cash App can also donate $10 for first, an organization that is helping to advance robotics and STEM education for young people around the world. And now, here's my conversation with Anka Dragana. When did you first fall in love with robotics?
I think it was a very gradual process, and it was somewhat accidental actually, because I first started getting into programming when I was a kid, and then into math, and then I decided computer science was the thing I was going to do, and then in college I got into AI, and then I applied to the robotics institute at Carnegie Mellon, and I was coming from this little school in Germany that nobody had heard of, but I had spent an exchange semester at Carnegie Mellon, so I had letters from Carnegie Mellon. So that was the only place. MIT said no, Berkeley said no, Stanford said no. That was the only place I got into. So I went there to the Robotics Institute, and I thought that robotics was a really cool way to actually apply the stuff that I knew and loved, like optimization. So that's how I got into robotics. I have a better story how I got into cars, which is I used to do mostly manipulation in my PhD, but now I do kind of a bit of everything application-wise, including cars. And I got into cars because I was here in Berkeley while I was a PhD student still for RSS 2014. Peter Gill organized it, and he arranged for, it was Google at the time, to give us rides in self-driving cars. And I was in a robot, and it was just making decision after decision the right call, and it was so amazing. So it was a whole different experience, right? Just fucking manipulation is so hard, you can't do anything, and there it was.
Was that the most magical robot you ever met? So like, for me too, me and Google self-driving car, the first time was like a transformative moment. Like I had two moments like that and Spot Mini. I don't know if you met Spot Mini from Austin Dynamics. I felt like I fell in love with it or something. Because I know how a Spot Mini works, right? It's just, I mean, there's nothing truly special. It's great engineering work, but the anthropomorphism that went on into my brain, like it came to life. Like it had a little arm, and it looked at me. She looked at me. I don't know. There was a magical connection there. It made me realize, wow, robots can be so much more than things that manipulate objects. They can be things that have a human connection. Was a self-driving car the moment? Like, was there a robot that truly inspired you?
I remember that experience very viscerally, riding in that car and being just wowed. I had there's a sticker that said I rode in a self-driving car, and it had this cute little firefly on it, and or a logo.
Oh, that was like the smaller one. The
the really cute one. Yeah. And I had my laptop, and I had that for years. I only changed my laptop out.
What about if we walk back? You mentioned optimization. Like what beautiful ideas inspired you in math, computer science, early on? Like, why get into this field? It seems like a cold and boring field like math. Like, what was exciting to you about it?
The thing is, I liked math from very early on. From 5th grade is when I got into the Math Olympiad and all of that.
Oh, you competed.
Yeah, this in Romania is like our national sport. These people understand. So I got into that fairly early, and little, maybe too just theory with no kind of, didn't really have a goal. And other than understanding, which is cool, I always liked learning and understanding, but there was no, okay, what am I applying this understanding to? And so I think that's how I got into more heavily into computer science, because it was kind of math meets something you can do tangibly in the world.
Do you remember like the first program you wrote?
Okay, the first program I written, what I kind of do, it was Q Basic in fourth grade.
Wow.
and it was drawing like a circle.
Graphics.
Yeah. That was, I don't know how to do that anymore. But in fourth grade. That's like the first thing that they taught me. It's like you could take a special, I wouldn't say it was an extracurricular, it's in a sense an extracurricular. So you could sign up for, dance or music or program. And I did the program thing. And my mom was like, what? Why?
Did you compete in program like these days? Probably that's like a big thing. There's a programming competition.
Mm-hmm.
Did that touch you at all?
I did a little bit of the computer science Olympiad, but not as serious as I did the math Olympiad. So it was programming. Yeah, it's basically here's a hard math problem solved with computers.
Yeah, it's more like algorithm.
Exactly, it's almost algorithm.
So, okay, you kind of mentioned the Google self-driving car, but outside of that, well, what's like who or what is your favorite robot, real or fictional, that captivated your imagination? I mean, I guess Google self-driving Firefly was a magical moment. Is there something else?
It was in the Firefly there. I think it was the Lexus, by the way. This was back then. But yeah, it's a good question. My favorite fictional robot is Wally, and I love how amazingly expressive it is. I'm just thinking a little bit about expressive motion because of things you were saying with you can do this and it's a head and it's a manipulator and what does it all mean? I like to think about that stuff. Pixar, I love animation.
Wally has big eyes, I think, or no.
Yeah, it has these and they move. So it goes and it's super cute. It's the way it moves, so expressive. The timing of that motion, what it's doing with its arm, what it's doing with these lenses is amazing. And so I really like that from the start. And then on top of that, I share this. It's a personal story I share with people, or when I teach about AI or whatnot. My husband proposed to me by building a Wally, and he actuated it so it's 7 degrees of freedom, including the lens thing, and it kind of came in, and he made it have like a, the belly box opening thing. So it just did that, and then it spewed out this box made out of Legos that moved very slowly, and then bam.
No.
It was quite it set a bar.
That could be like the most impressive thing I've ever heard. Okay.
That is such a connection to Wally. Long story short, I like Wally because I like animation and I like robots, and I like the fact that we still have this robots to this day.
How hard is that problem, do you think, of the expressivity of robots? Like with the Boston Dynamics, I never talked to those folks about this particular element. I've talked to them a lot, but it seems to be like almost an accidental side effect for them. That they weren't, I don't know if they're faking it, they weren't trying to. Okay, they do say that the gripper on it was not intended to be a face. I don't know if that's an honest statement, but I think they're legitimate. But so, do we automatically just anthropomorphize anything we can see about them? So, like, the question is, how hard is it to create a Wally type robot that connects so deeply with us? What do you think?
It's really hard, right? So it depends on what setting. So if you want to do it in this very particular narrow setting where it does only one thing and it's expressive, then you can get an animator. You have Pixar on call come in, design some trajectories. Anki had a robot called Cosmo where they put in some of these animations. That part is easy, right? The hard part is doing it not via these handcrafted behaviors, but doing it generally autonomously. Like I want robots. I don't work on, just to clarify, I used to work a lot on this. I don't work on that quite as much these days, but have the notion of having robots that, when they pick something up and put it in a place, they can do that with style, where you can say, well, this robot is succeeding at this task and it's confident versus it's hesitant versus maybe it's happy or it's disappointed about something, some failure that it had. Or I think that when robots move, they can communicate so much about internal states or perceived internal states that they have. And I think that's really useful and an element that we'll want in the future, because I was reading this article about how kids are being rude to Alexa because they can be rude to it and it doesn't really get angry, right? It doesn't reply, right? It just says the same thing. So I think there's, at least for that, for the correct development of children, learn that these things, and you kind of react differently. I know you walk in your home and you have a small robot, and if you're really pissed, presumably the robot should kind of behave slightly differently than when you're super happy and excited. But it's really hard because it's, I don't know, the way I would think about it, and the way I thought about it when it came to expressing goals or intentions for robots is, well, what's really happening is that instead of doing robotics where you have your state and you have your action space and you have your space, the reward function you're trying to optimize, now you kind of have to expand the notion of state to include this human internal state. What is the person actually perceiving? What do they think about the robots, something rather? And then you have to optimize that system. And that means you have to understand how your motion, your actions end up sort of influencing the observer's perception of you. And it's very hard to write math about that.
Right. So when you start to think about incorporating the human into the state model, apologize for the philosophical question, but how complicated are human beings, do you think? Like, can they be reduced to kind of almost like an object that moves and maybe has some basic intent? Or is there something that do we have to model things like mood and general aggressiveness and stuff? I mean, all these kinds of human qualities, or like deep qualities. Like, what's your sense?
How complicated it is.
How hard is the problem of human-robot interaction?
Yeah. Should we talk about what the problem of human-robot interaction is?
Yeah. So what
and
is
then
human-robot interaction?
And then talk about how that. Yeah. So, and by the way, I'm going to talk about this very particular view of human-robot interaction, right? Which is not so much of the social side or on the side of how do you have a good conversation with a robot? What should a robot's appearance be? It turns out that a robot's taller versus shorter just has an effect on how people act with them. So I'm not talking about that. But I'm talking about this very kind of narrow thing, which is if you want to take a task that a robot can do in isolation, in a lab out there in the world, but in isolation. And now you're asking, what does it mean for the robot to be able to do this task for, I don't know what its actual end goal is, which is to help some person. That ends up changing the problem in two ways. This way it changes the problem is that the robot is no longer the single agent acting. So you have humans who also take actions in that same space. Cars navigate around people, robots navigate around the people at office. I send the robot to over there in the cafeteria to get me a coffee. Then there's probably other people reaching for stuff in the same space. And so now you have your robot and you're in charge of the actions that the robot is taking. Then you have these people who are also making decisions and taking actions in that same space. And even if the robot knows what it should do and all of that, just coexisting with these people, right, kind of getting the actions to gel well, to mesh well together, that's sort of the kind of problem number one. And then there's problem number two, which goes back to this notion of if I'm a programmer, I can specify some objective for the robot to go off and optimize and specify the task. But if I put the robot in your home, presumably you might have your own opinions about, well, okay, I want my house clean, but how do I want it clean? And how should the robot move? How close to me it should come and all of that. And so I think those are the two differences that you have. You're acting around people and what you should be optimizing for should satisfy the preferences of that end user, not of your programmer.
Yeah, and the preferences thing is tricky. So figuring out those preferences, be able to interactively adjust to understand what the humans do. So it really boils down to understand the humans in order to interact with them and in order to.
Right.
So why is
now,
this hard?
why is understanding humans hard? So I think there's two tasks about understanding humans that in my mind are very, very similar, but not everyone agrees. So there's the task of being able to just anticipate what people will do. We all know that cars need to do this, right? We all know that, well, if I navigate around some people, the robot has to get some notion of, okay, where is this person going to be? So that's kind of the prediction side. And then there's what you were saying, satisfying the preference, right? So adapting to the person's preferences, knowing what to optimize for, which is more this inference side. What does this person want? What is their intent? What are their preferences? And to me, those kind of go together because I think that at the very least, if you can understand, if you look at human behavior and understand what it is that they want, then that's sort of the key enabler to being able to anticipate what they'll do in the future. Because I think that we're not arbitrary. We make these decisions that we make. We act in the way we do because we're trying to achieve certain things. And so I think that's the relationship between them. Now, how complicated do these models need to be in order to be able to understand what people want? So we've gotten a long way in robotics with something called inverse reinforcement learning, which is the notion of someone acts, demonstrates how they want this thing done.
What is inverse reinforcement learning?
Yeah. Right. So it's the problem of taking a behavior and infer reward function from it. Figure out what it is that behavior is optimal to expect. And it's a great way to think about learning human preferences in the sense of you have a car and the person can drive it, and then you can say, well, okay, I can actually learn what the person is optimizing for. I can learn their driving style, or you can have people demonstrate how they want the house clean, and then you can say, okay, this is I'm getting the trade-offs that they're making. I'm getting the preferences that they're making. And so we've been successful in robotics somewhat with this, and it's based on a very simple model of human behavior. It's remarkably simple, which is that human behavior is optimal in respect to whatever it is that people want, right? You make that assumption, and now you can kind of inverse them. That's why it's called inverse, well, really optimal control, but also inverse reinforcement learning. So this is based on utility maximization in economics. Back in the 40s, on the mortgage plan, we're like, okay, people are making choices by maximizing utility. Go. And then in the late 50s, we had Lewis and Shepard come in and say, people are a little bit noisy and approximate in that process. So they might choose something kind of stochastically with probability proportional to how much utility something has. There's a bit of noise in there. This has translated into robotics with something that we call Boltzmann rationality. So it's a kind of an evolution of inverse reinforcement learning that accounts for human noise. And we've had some success with that too for these tasks where it turns out people act noisily enough that you can't just do the vanilla version. You can account for noise and still infer what they seem to want based on this. And now we're hitting tasks where that's not enough. And
what are examples?
What are examples? So imagine you're trying to control some robot that's fairly complicated. You're trying to control a robot arm because if you're a patient with a motor impairment, you have this wheelchair-mounted arm and you're trying to control it around. Or one test that we've looked at with Sergey is, and his new thing is a lunar lander. So I don't know if you know this Atari game, it's called Lunar Lander. It's really hard. People really suck at landing the thing. Most of it just crash it left and right. Okay, so this is the kind of task. Imagine you're trying to provide some assistance to a person operating such a robot, where you want the kind of the autonomy to kick in, figure out what it is that you're trying to do. it's really hard to do that for, say, Lander because people are all over the place. And so they seem much more noisy than really rational. That's an example of a task where these models are kind of failing. And it's not surprising because, so it's, I'm talking about 40s utility, like 50s, noisy. The 70s came and behavioral economics started being a thing where people were like, no. People are not rational. People are messy and emotional and irrational and have all sorts of heuristics that might be domain specific, and they're just a mess.
Right.
So what does my robot do to understand what you want? And it's very that's why it's complicated. For the most part, we get away with pretty simple models until we don't, and then the question is, what do you do then? I have days when I wanted to, pack my bags and go home and switch jobs because it feels really daunting to make sense of human behavior enough that you can reliably understand what people want, especially as, robot capabilities will continue to get developed. You'll get these systems that are more and more capable of all sorts of things, and you really want to make sure that you're telling them the right thing. That thing will read it in human behavior.
So if I just sat here quietly and tried to understand something about you by listening to you talk, it would be harder than if I got to say something and ask you and interact with control. Can the robot help with understanding of the human by influencing the behavior by actually acting?
Yeah, absolutely. So one of the things that's been exciting to me lately is this notion that when you try to that when you try to think of the robotics problem as, okay, I have a robot and it needs to optimize for whatever it is that a person wants it to optimize, as opposed to maybe what a programmer said. That problem we think of as a human robot collaboration problem, in which both agents get to act, in which the robot knows less than the human because the human actually has access to, at least implicitly, to what it is that they want. They can't write it down, but they can talk about it. They can give all sorts of signals. They can demonstrate, but the robot doesn't need to sit there and passively observe human behavior and try to make sense of it. The robot can act too, and so there's these information gathering actions that the robot can take to sort of solicit responses that are actually informative. So, for instance, this is not for the purpose of assisting people, but with kind of back to coordinating with people with cars and all of that. One thing that Dorsa did was, so we were looking at cars being able to navigate around people, and you might not know exactly the driving style of a particular individual that's next to you, but you want to change lanes in front of them.
Navigating around other humans inside cars?
Yeah, good clarification question. So if you have an autonomous car and it's trying to navigate the road around human vehicles, similar things, ideas apply to pedestrians as well, but let's just take human vehicles. So now you're trying to change a lane. Well, you could be trying to infer this driving style of this person next to you. You'd like to know if they're sort of aggressive or defensive, if they're going to let you kind of go in or if they're going to not. and it's very difficult to just, when if you think that if you want to hedge your bets, maybe they're actually pretty aggressive, I should try this. You kind of end up driving next to them, right? And then you don't know because you're not actually getting the observations that you're getting. Wait, someone drives when they're next to you, and they just need to go straight. It's kind of the same, regardless if they're aggressive or defensive. And so you need to enable the robot to reason about how it might actually be able to gather information by changing the actions that it's taking. And then the robot comes up with these cool things where it kind of nudges towards you and then sees if you're going to slow down or not. If you slow down, it sort of updates its model of you and says, oh, okay, you're more on the defensive side, so now I can actually.
That's a fascinating test. That's so cool that you can just use your own actions to gather information. That feels like a totally open and exciting new way of robotics. I mean, how many people are even thinking about
a handful of us that say
It's rare because it's actually leveraging human. I mean, most roboticists, I've talked to a lot of colleagues and so on, are kind of, being honest, kind of afraid of humans.
because they're messy and complicated,
Yeah, exactly.
right? I understand. Going back to what we were talking about earlier, right now we're kind of in this dilemma of, okay, there are tasks that we can just assume people are approximately rational for, and we can figure out what they want, we can figure out their goals, we can figure out their driving styles, whatever. Cool. There are these tasks that we can't. So what do we do, right? Do we pack our bags and go home? And this, I've had a little bit of hope recently. And I'm kind of doubting myself because what do I know that 50 years of behavioral economics hasn't figured out? But maybe it's not really in contradiction with the way that field is headed. But basically, one thing that we've been thinking about is instead of kind of giving up and saying people are too crazy and irrational for us to make sense of them, maybe we can give them a bit the benefit of the doubt. And maybe we can think of them as actually being relatively rational, but just under different assumptions about the world, about how the world works, about we don't have. When we think about rationality, this assumption is, well, they're rational and they're all the same assumptions and constraints as the robot, right? What if this is the state of the world? That's what they know. This is the transition function. That's what they know. This is the horizon. That's what they know. But maybe kind of this difference, the reason they can seem a little messy and hectic as with robots is that perhaps they just make assumptions or have beliefs. So
I mean, that's another fascinating idea that this our kind of anecdotal desire to say that humans are rational, perhaps grounded in behavioral economics, is that we just don't understand the constraints that there are ones under which they operate. And so our goal shouldn't be to throw our hands up and say they're irrational. It's to say, let's try to understand what are the constraints.
What it is that they must be assuming that makes this behavior make sense.
That's
Good
true.
life lesson, right? Good life lesson.
That's true. It's just outside of robotics. That's just good to. That's communicating with humans. That's just a good to assume that you just don't sort of empathy, right?
Maybe there's something you're missing, and it's it especially happens to robots because they're kind of dumb and they don't know things, and oftentimes people are just super irrational and that they actually know a lot of things robots don't. Sometimes, like with the lunar lander, the robot knows much more. So it turns out that if you try to say, look, maybe people are operating this thing, but assuming a much more simplified physics model, because they don't get the complexity of this kind of craft or the robot arm with 7 degrees of freedom with these inertias and whatever. So maybe they have this intuitive physics model, which is not, this notion of intuitive physics is something that is studied actually in cognitive science, books like Josh Dennerbaum, Tom Hippett's work on this stuff. And what we found is that you can actually try to figure out what physics model kind of best explains human actions. And then you can use that to sort of correct what it is that they're commanding the craft to do. So they might, be sending the craft somewhere, but instead of executing that action, you can sort of take a step back and say, according to their intuitive, if the world worked according to their intuitive physics model, where do they think that the craft is going? Where are they trying to send it to? And then you can use the real physics, like the inverse of that, to actually figure out what you should do so that you do that instead of where they were actually sending you in the real world. And I kid you not, it worked. People land the damn thing, and in between the two flags and all that. So it's not conclusive in any way, but I'd say it's evidence that maybe we're kind of underestimating humans in some ways when we're giving up and saying, yeah, they're just crazy, noisy.
So then you try to explicitly model the kind of worldview that they have.
But they have. That's right. It's not too. I mean, there's things in behavioral economics too that for instance I've touched upon the planning horizon. So there's the idea that, but there's the rationality essentially. The idea that maybe we work under computational constraints. And I think kind of our view recently has been take the Bellman update in AI and just break it in all sorts of ways by saying state, no, the person doesn't get to see the real state. Maybe they're estimating somehow. Transition function, No. Even the actual reward evaluation, maybe they're still learning about what it is that they want. Like when you watch Netflix and you have all the things and then you have to pick something. Imagine that the AI system interpreted that choice as just as the thing you prefer to see it. How are you going to know? You're still trying to figure out what you like, what you don't like, etc. So I think it's important to also account for that. It's not irrationality, but they're doing the right thing under the things that they know.
Yeah, that's brilliant. You mentioned recommender systems. What kind of, when we're talking about human robot interaction, what kind of problem spaces are you thinking about? So, is it robots, like wheeled robots with autonomous vehicles? Is it object manipulation? Like when you think about human robot interaction in your mind, and maybe I'm sure you can speak for the entire community of human robot interaction. So, like, what are the problems of interest here? And does it, I kind of think of open domain dialogue as human robot interaction, and that happens not in the physical space, but it could just happen in the virtual space. So where's the boundaries of this field about the things we've been talking about?
Yeah, so I try to find kind of underlying, I don't know what to even call them. Like I try to work on, I might call what I do the kind of work on the foundations of algorithmic human robot interaction and try to make contributions there. And it's important to me that whatever we do is actually somewhat domain agnostic when it comes to, is it about, autonomous cars, or is it about quadrators, or is it about, it's just sort of the same underlying principles apply. Of course, when you're trying to get a particular domain to work, you usually have to do some extra work to adapt that to that particular domain. But these things that we were talking about around, well, how do you model humans? It turns out that a lot of systems need to, quote, benefit from a better understanding of how human behavior relates to what people want and need to predict human behavior, physical robots of those sorts, and beyond that. And so I used to do manipulation. I used to be, picking up stuff, and then I was picking up stuff with people around. And now it's sort of very broad when it comes to the application level, but in a sense very focused on, okay, how does the problem need to change? The algorithm need to change when we're not doing the robot by itself, emptying the dishwasher, but we're stepping outside of that.
I thought that popped into my head just now. On the game theoretic side of things, you said this really interesting idea of using actions to gain more information. But if we think of sort of game theory, the humans that are interacting with you, the robot, thinking the identity of the robot. Yeah, is they also have a world model with you, and you can manipulate that. I mean, if we look at autonomous vehicles, people have a certain viewpoint. You said with the kids, people see Alexa in a certain way. Is there some value in trying to also optimize how people see you as a robot?
Mm-hmm.
Is that a little too far away from the specifics of what we can solve right now?
So, both, right? So It's really interesting, and we've seen a little bit of progress on this problem, on pieces of this problem. So you can, again, it kind of comes down to how complicated does the human model need to be. But in one piece of work that we were looking at, we said, okay, there's these parameters that are internal to the robot, and they're what the robot is about to do, or maybe what objective, what driving style the robot has, or something like that. And what we're going to do is we're going to set up a system where part of the state is the person's beliefs over those parameters. And now when the robot acts, that the person gets new evidence about this robot internal state. And so they're updating their mental model of the robot, right? So if they see a card that sort of cuts someone off, like, oh, that's an aggressive card, they don't want, right? If they see sort of a robot head towards a particular door, they're like, oh, yeah, the robot's trying to get to that door. So So this thing that we have to do with humans to try to understand their goals and intentions, humans are inevitably going to do that to robots. And then that raises this interesting question that you asked, which is, can we do something about that? This is going to happen inevitably, but we can sort of be more confusing or less confusing to people. And it turns out you can optimize for being more informative and less confusing if you have an understanding of how your actions are being interpreted by the human, how they're using these actions to update their belief. And honestly, all we did is just Bayes' rule. Basically, okay, person has a belief, they see an action, they make some assumptions about how the robot generates its actions, presumably as being rational, because robots are rational. It's reasonable to assume that about them. And then they incorporate that new piece of evidence, and Bayesian sense in their belief, and they obtain a posterior. And now the robot is trying to figure out what actions to take, such that it steers the person's belief to put as much probability mass as possible on the correct parameters.
So that's kind of a mathematical formalization of that. But my worry, and I don't know if you want to go there with me, but I talk about this quite a bit. The kids talking to Alexa disrespectfully worries me. I worry in general about human nature. Like I said, I grew up in the Soviet Union, World War II, up in June too, so with the Holocaust narrative. I just worry about how we humans sometimes treat the other, the group or the other, whatever it is. Through human history, the group that's the other has changed. But it seems like the robot will be the next to other. And one thing is, it feels to me that robots don't get no respect.
They get shoved around.
And is there one at the shallow level, for a better experience, it seems that robots talk back a little bit. Like, my intuition, I mean, most companies, from Roomba, autonomous vehicle companies, might not be so happy with the idea that a robot has a little bit of an attitude. But it feels to me that that's necessary to create a compelling experience. And we humans don't seem to respect anything that doesn't give us some attitude. That, or like mix of mystery and attitude and anger and that threatens us subtly, maybe passive aggressively. I don't know. It seems like we humans, need that. What do you? Is there something you have thoughts on this?
Okay, I'll give you two thoughts on it.
Sure.
One is it's we respond to someone being assertive, but we also respond to someone being vulnerable. So I think robots. My first thought is that robots get shoved around and bullied a lot because they're sort of tempting. They're sort of showing off, or they appear to be showing off. And so I think going back to these things we were talking about in the beginning of making robots a little more expressive, a little bit more like, that wasn't cool to do, and now I'm bummed, right? I think that can actually help people kind of help with anthropomorphize and respond to that. Even that, though, the emotion being communicated is not in any way a real thing, and people know that it's not a real thing because they know it's just a machine. We're still interpreting. We watch. There's this famous psychology experiment with little triangles and dots on a screen, and the triangle is chasing the square, and you get really angry at the darn triangle because why is it not leaving the square alone? So that's we can't help. So that was the first thought.
The vulnerability is really interesting. I think of like being pushing back, being assertive as the only mechanism of forming a connection, getting respect, perhaps vulnerability. Perhaps there's other mechanisms that are less than it.
Yeah.
So,
I think a little bit, yes. But then this other thing that we can think about is it goes back to what you were saying, that interaction is really game theoretic, right? So the moment you're taking actions in a space, humans are taking actions in that same space, but you have your own objective, which is you're a car, you need to get your passenger to the destination, and then the human nearby has their own objective, which somewhat overlaps with you, but not entirely. You're not interested in getting into an accident with each other, but you have different destinations, and you want to get home faster, and they want to get home faster, and that's a general sum game at that point. And so I think that's what treating it as such is kind of a way we can step outside of this kind of mode that where you try to anticipate what people do and you don't realize you have any influence over it while still protecting yourself because you're understanding that people also understand that they can influence you. And it's just kind of back and forth. There's this negotiation, which is really, we're really talking about different equilibria of a game. The very basic way to solve coordination is to just make predictions about what people will do and then stay out of their way. And that's hard for the reasons we talked about, which is how you have to understand people's intentions implicitly, explicitly, who knows, but somehow you have to get enough of an understanding of that to be able to anticipate what happens next. And so that's challenging. But then it's further challenged by the fact that people change what they do based on what you do because they don't plan in isolation either, right? So when you see cars trying to merge on a highway and not succeeding, one of the reasons this can be is because they look at traffic that keeps coming, they predict what these people are planning on doing, which is to just keep going, and then they stay out of the way because there's no feasible plan, right? Any plan would actually intersect with one of these other people, so that's bad. So you get stuck there. So now, kind of, if you start thinking about it as no, actually, these people change what they do depending on what the car does. If the car actually tries to kind of inch itself forward, they might actually slow down and let the car in.
Yeah, what did he say? Right. All right. Is that the move? How do you think this project's going to do? I've seen it. It sounds like this project is more about a game than it is a project. Am I wrong? Gamify and tokenization. Hey, you want to play Scrabble? You want to play Scrabble against me? All right, I'll send you an invite right now. All right, I'm sending you an invite right now. Dog, I don't know how to do this with you. Yeah, what the fuck is this? Scrabble. Those are bonus points. Have you ever played Scrabble? Well, it's your turn. You gotta put down some letters. You've got like 20 seconds to put something down. Put something down here. And then hit submit. So, that's not how you do it. All right, just resign. Up in the right corner, press resign. Yeah. You hit resign. No, go back to the game and press resign. It's it's all back. Now in the upper right corner. There you go. All right, let's play golf. Yes, let's play mini golf. Excellent. Wonderful. Mini golf. You're going down, Scott. What happens when a Jewish person gets in? It means that the Jew is involved in the congregation. Dude, I get so much shit because being online 24/7, I don't like everything but
Um, Now taking advantage of that, well, that that's kind of the next level. We call this like this underactuated system idea, where underactuated system robotics, but it's kind of it's you don't you influence these other degrees of freedom, but you don't get to decide what
Yeah,
the do.
I've somewhere seen you mentioned it. The human element in the picture as underactuated. So you understand underactuated robotics is you know that you can't fully control the system. So
You can't go in arbitrary directions in the configuration space.
under your control.
Yeah, it's a very simple way of underactuation, where basically there's literally these degrees of freedom that you can control, and these degrees of freedom that you can't, but you can. And I think that's the important part, is that they don't do whatever regard what you do, that what you influence is what they end up doing.
I just also like the poetry of calling human robot interaction underactuated robotics problem. And you also mentioned sort of nudging. It seems that I don't know. I think about this a lot in the case of pedestrians. I've collected hundreds of hours of videos. I like to just watch pedestrians,
Mm-hmm.
and it seems that
It's a funny hobby.
yeah, it's weird because I learn a lot. I learn a lot about myself, about it from watching pedestrians, watching people in their environment. And basically, crossing the street is like you're putting your life in a line. I don't know, tens of millions of times in America every day. These people are just like playing this weird game of chicken when they cross the street, especially when there's some ambiguity about the right of way. That has to do either with the rules of the road or with the general personality of these perception based on the time of day and so on. And this nudging idea, I don't, it seems that people don't even nudge; they just aggressively make a decision. Somebody, there's a runner that gave me this advice. I sometimes run in the street, and not the street, sidewalk, and he said that if you don't make eye contact with people when you're running, they will all move out of your way.
It's called civil inattention.
Civil inattention, that's the thing. But it works. What is that? My sense was if you communicate like confidence in your actions, that you're unlikely to deviate from the action that you're following. That's a really powerful signal to others that they need to plan around your actions, as opposed to nudging where you're sort of hesitantly. The hesitation might communicate that you're still in the dance and the game that they can influence with their own actions. I've recently had a conversation with Jim Keller, who's a legendary chip architect, but he also led the autopilot team for a while. And his intuition that driving is fundamentally still like a ballistics problem. Like you can ignore these human elements, but it's just not hitting things. And you kind of learn the right dynamics required to do the merge and all those kinds of things. And then my sense is, and I don't know if I can provide sort of definitive proof of this, but my sense is like an order of magnitude or more difficult when humans are involved, not simply object collision avoidance problem. Where does your intuition? Of course, nobody knows the right answer here, but where does your intuition fall on the fundamental difficulty of the driving problem of humans are involved?
Yeah, good question. I haven't been on this. Imagine downtown San Francisco. Yeah. It's crazy, busy, everything. Okay, now take all the humans out. No pedestrians, no human-driven vehicles, no cyclists, no people on little electric scooters zipping around, nothing. I think we're done. I think driving at that point is done. We're done. There's nothing really still needs to be solved about that.
Well, let's pause there. I think I agree with you, and I think a lot of people that would hear would agree with that. But we need to sort of internalize that idea. So what's the problem there? We might not quite yet be done with that. A lot of people kind of focus on the perception problem. But a lot of people with driving to how close are we to solving, being able to detect all the drivable area, the objects in the scene. Do you see that as how hard is that problem? So your intuition there behind your statement was we might have not solved it yet, but we're close to solving the perception problem.
I think the percent problem. I mean, and by the way, a bunch of years ago, this would not have been true. And a lot of issues in the space were coming from the fact that we don't really, we don't know what's where. But I think it's fairly safe to say that at this point, although you could always improve on things and all of that, you can drive to downtown San Francisco if there are no people around. There's no really perception issues then. And perception is hard, but yeah, it's made a lot of progress on the perception side. I've undermined the difficulty. I think everything about robotics is really difficult, of course. The planning problem, the control problem, all very difficult. But I think what makes it really, it might be. I mean, I picked downtown San Francisco. Adapting to, well, now it's snowing, now it's no longer snowing, now it's slippery in this way, now it's the dynamics part I could imagine being still somewhat challenging. But
the thing that I think worries us is our intuition about good there is your perceptual problem is the edge case. Downtown San Francisco, the nice thing, it's not actually it may not be a good example because
because crazy construction zones and all that.
But the thing is you're traveling at slow speed, so like it doesn't feel dangerous. To me, what feels dangerous is highway speed when everything is to us humans.
I'm assuming lighter here, by the way. I think it's kind of irresponsible to not use LiDAR. That's just my personal opinion.
That's a,
I mean, depending on your use case, but I think like, you know, if you have the opportunity to use LiDAR, you could. Then a lot of cases you might not.
good. Your intuition makes more sense now. So you don't think vision.
I really just don't know enough to say, well, vision alone, what's like. There's a lot of, how many cameras do you have? How are you using them? I don't know. There's all sorts of details. I imagine there's stuff that's really hard to actually see. You know, how you deal with exactly what you were saying. Stuff that people would see that you don't. I think I have more of my intuition comes from systems that can actually use LiDAR as well.
Yeah, until we know for sure it makes sense to be used with LiDAR. That's kind of the safety focus. But then there's sort of I also sympathize with the Elon Musk statement of LiDAR as a crutch. It's a fun notion to think that the things that work today is a crutch for the invention of things that will work tomorrow, right? Like it's kind of true in the sense that, you know, we want to stick to the comfort. You see this in academic and research settings all the time. The things that work force you to not explore outside, think outside the box. I mean, that happens all the time. The problem is in safety critical systems, you kind of want to stick with the things that work. So it's an interesting and difficult trade-off in the case of real world sort of safety critical robotic systems. But so your intuition is, just to clarify,
Yes.
how hard is how hard is driving? Are we years, decades away from solving it? But perhaps actually the years is the thing I'm asking. It doesn't matter what the time is. Do you think how many breakthroughs are we away from solving this robots or actual problem to get this right?
I think in a sense, it really depends. I think that we were talking about how, well, look, it's really hard because anticipating what we don't do is hard, and on top of that, playing the game is hard. I think we sort of have the fundamental, some of the fundamental understanding for that, and we already see that these systems are being deployed in the real world. You know, even driverless. There's, I think now, a few companies that don't put driver in the car.
Yeah,
Some small areas.
I got a chance to. I went to Phoenix and I shot a video with Waymo, and you need to get that video out. People give me slack with it. Incredible engineering work being done there, and it's one of those other seminal moments for me in my life to be able to. It sounds silly, but to be able to drive without a ride, without a driver in the seat. I mean, that was an incredible robotics. I was driven by a robot, and without being able to take over, without being able to take the steering wheel. That's a magical moment. So in that regard, those domains, at least for like Waymo, they're solving that human. They're going fast. It felt fast because you're like freaking out at first. This is my first experience. But it's going like the speed limit, right? 30, 40, whatever it is. And it deals with them quite well. It detects them and it negotiates the intersections, left turns, and all that. So at least in those domains, it's solving them. The open question for me is like, how quickly can we expand? That's the, outside of the weather conditions, all those kinds of things, how quickly can we expand to like cities like San Francisco?
Yeah, and I wouldn't say that it's just, now it's just pure engineering and probably and by the way, I'm speaking kind of very generally here as hypothesizing, but I think that there are successes, and yet no one is everywhere out there. So that seems to suggest that things can be expanded and can be scaled, and we know how to do a lot of things, but there's still probably, new algorithms or modified algorithms that you still need to put in there as you learn more about new challenges that you get faced with.
How much of this problem do you think you can learn? And challenges, the success of
Well,
machine
one
learning
time
and
well,
also learning.
this
How
is
much
what you want
can
to
you
get
learn
off the
from
back
certain
wall.
data from scratch? And how much most of the success of house ecosystem from a lot of heuristics and rule-based stuff on top, like human expertise injected, forced into the system to make it work. What's your sense? How much? What will be the role of learning in the near term?
I think on the one hand that learning is inevitable here, right? I think on the other hand that when people characterize the problem as it's a bunch of rules that some people wrote down, versus it's an end-to-end RL system or imitation learning, then maybe there's something missing from maybe that's more. So, for instance, I think a very, very useful tool in this sort of problem, both in how to generate the car's behavior and robots in general, and how to model human beings, is actually planning, search optimization, right? So robotics is the sequential decision-making problem, and when a robot can figure out on its own how to achieve its goal without hitting stuff and all that stuff, right? All the good stuff for motion planning 101. I think of that as very much AI, not this is some rule or something. There's nothing rule based around that, right? It's just you're searching through space and figuring out, you're optimizing through space and figure out what seems to be the right thing to do. And I think it's hard to just do that because you need to learn the models of the world. And I think it's hard to just do the part where you don't bother with any of that, because then you're saying, well, I could do imitation, but then when I go off distribution, I'm really screwed. Or you can say, I can do reinforcement learning, which adds a lot of robustness, but then you have to do either reinforcement learning in the real world, which sounds a little challenging, or that trial and error, or you have to do reinforcement learning in simulation. And then that means, well, guess what? You need to model things, at least to model people, model the world enough that whatever policy you get of that is like actually fine to roll out in the world and do some additional learning there. So,
do you think simulation, by the way, just a quick tangent, has a role in the human-robot interaction space? Like, is it useful? It seems like humans, everything we've been talking about is difficult to model and simulate. Do you think simulation has a role in this space?
I do. I think so because you can take models and train with them ahead of time, for instance. You can.
But the models, sorry to interrupt, the models are sort of human constructed or not?
I think they have to be a combination, because if you get some human data and then you say, this is how I'll get this into my model of the person, whether for simulation and training or for just deployment time, and that's what I'm planning with as my model of how people work. Regardless, if you take some data and you don't assume anything else, you just say, okay, this is some data that I've collected. Let me fit a policy to how people work based on that. What happened is you collected some data and some distribution, and then now your robot gets a best response, right? It's sort of, what should I do if this is how people work? And easily goes off of distribution, where that model that you built of the human completely sucks, because out of distribution you have no idea, right? You think of all the possible policies, and then you take only the ones that are consistent with the human data that you've observed. That still leaves a lot of things can happen outside of that distribution where you're confident that you know what's going on.
By the way, that's I've gotten used to this terminology of distribution, but it's such a machine learning terminology because it kind of assumes distribution is referring to the data that you've
set of states that you encounter.
That you've encountered so far at training time.
Yeah.
But it kind of also implies that there's a nice statistical model that represents that data. So out of distribution, it's like, I don't know, it raises to me philosophical questions of how we humans
I suck at
reason out of distribution,
I suck
reason about things that are completely we haven't seen before.
And so, and what we're talking about here is how do we reason about what other people do in situations where we haven't seen that, and somehow we just magically navigate that. I can anticipate what will happen in situations that are even novel in many ways, and I have pretty good. I don't always get it right, but I may be a little uncertain and so on. But I think it's this that if you just rely on data, there's just too many possibilities. There's too many policies out there that data. And by the way, it's not just state; it's really kind of history of state, because to really be able to anticipate what the person will do, it kind of depends on what they've been doing so far, because that's the information you need to kind of, at least implicitly, sort of say, oh, this is the kind of person that this is. This is probably what they're trying to do. So anyway, it's like you're trying to map history of states. So actually, there's many mappings.
And history meaning like the last few seconds,
Yeah.
or the last few minutes, or the last few months.
Who knows how much you need, right? In terms of if your state is really like the positions of everything or whatnot, and velocities. Who knows how much you need? And then there's so many mappings. And so now you're talking about how do you regularize that space? What priors do you impose? Or what's the inductive bias? So, there's all very related things to think about it. Basically, what are assumptions that we should be making such that these models actually generalize outside of the data that we've seen? And now you're talking about, well, I don't know, what can you assume? Maybe you can assume that people actually have intentions, and that's what drives their actions. Maybe that's the right thing to do when you haven't seen data very nearby that tells you otherwise. I don't know. It's a very open question.
Do you think that one of the dreams of intelligence is to solve common sense reasoning, whatever the heck that means? Do you think something like common sense reasoning has to be solved in part to be able to solve this dance of human-robot interaction in the driving space, or human-robot interaction in general? You have to be able to reason about these kinds of common sense concepts of physics, of all the things we've been talking about humans that I don't even know how to express them with words, but the basics of human behavior, of fear of death. So, to me, it's really important to encode in some kind of sense, maybe not implicit, but it feels that it's important to explicitly encode the fear of death, that people don't want to die. Because it seems silly, but the game of chicken that involves a pedestrian crossing the street is playing with the idea of mortality. We really don't want to die. It's not just a negative reward. I don't know. It just feels like all these human concepts have to be encoded. Do you share that sense, or is it philosopher making out to be?
I think it might be simpler. And I'm no person who likes to complicate things. I think it might be simpler than that. Because it turns out, for instance, if you say model people in the very, I'll call it traditional way. I don't know if it's fair to look at it as a traditional way, but calling people as, okay, they're rational somehow, the utilitarian perspective. Well, in that, once you say that, you automatically capture that they have an incentive to keep on being. Stuart likes to say, you can't fetch the coffee if you're dead.
Stuart Russell, by the way. That's a good line.
So when you're sort of treating agents as having these objectives, these incentives, humans or artificial, you're kind of implicitly modeling that they'd like to stick around so that they can accomplish those goals. So I think in a sense, maybe that's what draws me so much to the rationality framework. Even though it's so broken, we've been able to. It's been such a useful perspective, and like we were talking about earlier, what's the alternative? I give up and go home, or I just do complete black boxes, but then I don't know what to assume out of distribution and come back to this. It's been a very fruitful way to think about the problem in a very more positive way, right? It's just people aren't just crazy. Maybe they make more sense than we think. But But I think we also have to somehow be ready for it to be wrong, be able to detect when these assumptions aren't holding, all of that stuff.
Let me ask you another small side of this that we've been talking about, the pure autonomous driving problem. But there's also a relatively successful, already deployed out there in what you may call like level 2 autonomous or semi-autonomous vehicles. Whether that's Tesla Autopilot, I've worked quite a bit with Cadillac Super Boost system, which has a driver-facing camera that detects your state. There's a bunch of basically lane-centric systems. What's your sense about this kind of way of dealing with the human-robot interaction problem by having a really dumb robot and relying on the human to help the robot out to keep them both alive? Is that from the research perspective, how difficult is that problem? And from a practical deployment perspective, is that a fruitful way to approach this human robot interaction problem?
I think what we have to do out there is to not make it seems like some of these systems on whole are making this underlying assumption that if so I'm a driver and I'm now really not driving but supervising and my job is to intervene. And so we have to be careful with this assumption that if I'm supervising, I will be just as safe as when I'm driving. Like that I will, if I wouldn't get in some kind of accident if I'm driving, I will be able to avoid that accident when I'm supervising too. And I think I'm concerned about this assumption from a few perspectives. So from a technical perspective, it's that when you let something kind of take control and do its thing, and it depends on what that thing is, obviously, and how much it's taking control and what things are you trusting it to do. But if you let it do its thing and take control, it will go to what we might call off policy from the person's perspective state. So states that the person wouldn't actually find themselves in if they were the ones driving. And the assumption that the person functions just as well there as they function in the states that they would normally encounter is a little questionable. Now, another part is the kind of the human factor side of this, which is that I don't know about you, but I think I definitely feel like I'm experiencing things very differently when I'm actively engaged in the task versus when I'm a passive observer. Even if I try to stay engaged, right, it's very different than when I'm actually actively making decisions. And you see this in life in general. Like you see students who are actively trying to come up with the answer, learn this thing better than when they're passively told the answer. I think that's somewhat related. And I think people have studied this in human factors for airplanes. And I think it's actually fairly established these two are not the same. So,
yeah, on that point, because I've gotten a huge amount of heat on this, and I stand by it.
okay.
Because I know the human factors community well, and the work here is really strong, and there's many decades of work showing exactly what you're saying. Nevertheless, I've been continuously surprised that much of the predictions of that work has been wrong, what I see. So what we have to do, I still agree with everything you said. We have to be a little bit more open-minded. I'll tell you, there's a surprising things that like everything you said, the words actually exactly correct. But it doesn't say, what you didn't say is that these systems are, you said you can't assume a bunch of things. But we don't know if these systems are fundamentally unsafe. That's still unknown. There's a lot of interesting things. Like, I'm surprised by the fact, not the fact, that what seems to be anecdotal from large data collection, but also from just talking to a lot of people. When in the supervisory role, semi-autonomous systems that are sufficiently dumb, at least, that might be a key element, is the systems have to be dumb. The people are actually more energized, so they're actually better. They're better at observing the situation. So there might be cases in systems, if you get the interaction right, where you, as a supervisor, will do a better job of with the system together.
I agree. I think that is actually really possible. I guess maybe I'm pointing out that if you do it naively, you're and implicitly assuming something, that assumption might actually really be wrong. But I do think that if you explicitly think about what the agent should do so that the person still stays engaged, what the so that you essentially empower the person who want they could that's the really the goal, right? If you still have a driver, so you want to empower them to be so much better than they would be by themselves. And that's different, very different mindset than I want them to basically not drive and but be ready to sort of take over.
So one of the interesting things that we're talking about is the rewards that they seem to be fundamental to the way robots behave. So broadly speaking, we've been talking about utility functions now, but comment on how do we approach the design of reward functions? Like, how do we come up with good reward functions?
Well, really good question because the answer is we don't. This was, I used to think, I used to think about how, well, it's actually really hard to specify rewards for interaction because it's really supposed to be what the people want, and then you really, for how you have to customize what you want to do to the end user. But I kind of realized that even if you take the interactive component away, it's still really hard to design reward functions. So what do I mean by that? I mean, if we assume this sort of AI paradigm in which there's an agent and its job is to optimize some objectives and reward, utility, loss, whatever, cost. If you write it out, maybe it's a set depending on the situation, whatever it is. If you write it out and then you deploy the agent, you'd want to make sure that whatever you specify incentivizes the behavior you want from the agent in a situation that the agent will face. Right? So I do motion planning on my robot arm. I specify this function like, this is how far away I should try to stay. So much I stay away from people, and there's so much it matters to be able to be efficient and blah, 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 right? I need to make sure that whatever I specify, those constraints or trade-offs or whatever they are, that when the robot goes and solves that problem in every new situation, that behavior is the behavior that I want to see. And what I've been finding is that we have no idea how to do that. But basically, what I can do is I can sample, I can think of some situations that I think are representative of what the robot will face. And I can tune and add and tune some reward function until the optimal behavior is what I want on those situations. Which, first of all, is super frustrating because through the miracle of AI, we don't have to specify rules for behavior anymore, right? We were saying before, the robot comes up with the right thing to do. You plug in the situation, it optimizes, right? In that situation, it optimizes. But you have to spend still a lot of time on actually defining what it is that criterion should be. Make sure you didn't forget about 50 bazillion things that are important and how they all should be combining together to tell the robot what's good and what's bad and how good and how bad. And so I think this is a lesson that, I don't know, kind of, I guess I closed my eyes to it for a while because I've been, tuning cost functions for 10 years now. But it's really strikes me that, we've moved the tuning and the designing of features or whatever from the behavior side into the reward side. And yes, I agree that there's way less of it. It still seems really hard to anticipate any possible situation and make sure you specify a reward function that when optimized will work well in every possible situation.
So you're kind of referring to unintended consequences or just in general any kind of suboptimal behavior that emerges outside of distribution.
Suboptimal behavior that is, actually optimal. I mean, it's like a the idea about independent concepts. You know, it's optimized for what you specified, but it's not what you want. And there's a difference.
But that's not fundamentally a robotics problem, right? That's a human problem. So like
that's the thing, right? So there's Goodhart's law, which is you set a metric for an organization, and the moment it becomes a target that people actually optimize for, it's no longer a good metric.
What's it called?
Goodhart's law.
Goodhart's law. So the moment you specify a metric, stop doing this job.
Yeah, it stops doing its job. So there's such thing as optimizing for things and failing to think ahead of time of all the possible things that might be important. And so that's interesting because you started working about on reward learning from the perspective of customizing to the end user, but it really seems like it's not just the interaction with the end user that's a problem of the human and the robot collaborating so that the robot can do what the human wants, right? This kind of back and forth, the robot probing, the person being informative, all of that stuff might be actually just as applicable to this kind of maybe new form of human-robot interaction, which is the interaction between the robot and the expert programmer, roboticist, designer in charge of actually specifying what the heck the robot should do and specifying the task for the robot.
Fascinating. It's so cool. Like collaborating.
Right, collaborating on the reward design. And so what does it mean, right? What is it when we think about the problem not as someone specifies all of your job is to optimize and you start thinking about you're in this interaction and this collaboration. And the first thing that comes up is when the person specifies a reward, it's not, gospel. It's not like the letter of the law. It's not the definition of the reward function you should be optimizing. Because they're best, but they're not some magic reward. And the sooner we start understanding that, I think the sooner we'll get to more robots that function better in different situations. And then you have kind of say, okay, well, it's almost like over learning, and putting too much weight on the reward specified by definition, and maybe leaving a lot of other information on the table. Like, what are other things we could do to actually communicate to the robot about what we want them to do besides attempting to specify?
Yeah, you have this awesome, and again, I love the poetry of leaked information. So you mentioned humans leak information about what they want. Leak reward signal for the robot. So how do we detect these leaks?
Yeah, what are these leaks?
But I don't know. Those were just recently, so I read it out of nowhere from you. It's gonna stick with me for a while for some reason because it's not explicitly expressed to cut out leaks indirectly from our
Yeah, absolutely. So I think maybe some surprising bits, right? So we were talking before about I'm a robot arm, needs to move around people, carry stuff, put stuff away, all of that. And now imagine that the robot has some initial objectives that the programmer gave it, so they can do all these things capable of doing that. And now I noticed that it's doing something that maybe is coming too close to me, right? And maybe I'm the designer, maybe I'm the end user, and this robot is doing it.
I love this song.
And I push it away.
Dude, this is so
I push it away because it's a reaction to what the robot is trying to do. And this is what we call physical robot interaction. And now there's a lot of interesting work on how the heck to respond to physical robot interaction. What should the robot do if such an event occurs? And there's sort of different schools of thought. Well, you can sort of treat it to control theoretically and say this is a disturbance that you must reject. You can sort of treat it more kind of heuristically and say I'm going to go into some like gravity compensation mode so that I'm easily move forward around. I'm going to go in the direction that the person pushed me. And to us, part of the realization has been that is signal that can describe the reward, because if my robot was moving in an optimal way and I intervened, that means that I disagree with its notion of optimality. Right? Whatever it thinks is optimal is not actually optimal. And sort of optimization problems aside, that means that the cost versus reward function is is incorrect, or at least is not what I want it to be.
How difficult is that signal to interpret and make actionable? So like this connects to our autonomous vehicle discussion. Like in the semi-autonomous vehicle or autonomous vehicle, the safety driver disengages the car. Like they could have disengaged it for a million reasons.
Yeah, so that's true. Again, it comes back to can you structure a little bit your assumptions about how human behavior relates to what they want. And you can, one thing that we've done is literally just treated this external torque that they apply as, when you take that and you add it with what the torque the robot was already applying, that overall action is probably relatively optimal with respect to whatever it is that the person wants. And then that gives you information about what it is that they want. So you can learn that people want to stay further away from that. Now, you're right that there might be many things that explain just that one thing. Might need much more data than that for the person to be able to shape your reward function over time. You can also do this info gathering stuff that we were talking about. Now that we've done that in that context, just to clarify, but it's definitely something we thought about, where you can have the robot start acting in a way, like if there's a bunch of different explanations, right? It moves in a way where it's easy to correct it in some other way or not, and then kind of actually plans its motion so that it can disambiguate and collect information about what you want. Anyway, so that's one way. That's sort of leaked information. Maybe even more subtle leaked information is if I just press the e-stop, right? I'm doing it out of panic because the robot is about to do something bad. There's again information there, right? Okay, the robot should definitely stop. But it should also figure out that whatever it was about to do was not good. So it made it stop for a while, was a better trajectory for it than whatever it is that it was about to do. And that again is information about what are my preferences.
Speaking of e-stop, what are your expert opinions on the 3 laws of robotics from Isaac Asimov? That you don't harm humans, obey orders, protect yourself. It's such a silly notion, but I speak to so many people these days, just regular folks, my parents and so on, about robotics, and they kind of operate in that space of, imagining our future with robots, thinking what are the ethical, how do we get that dance right? I know the 3 laws might be a silly notion, but do you think about like what universal reward functions there might be that we should enforce on the robots in the future, or is that a little too far out? And does it, or is the mechanism that you just described? It should be 3 laws. It should be constantly adjusted.
I think it should constantly be adjusted. The issue with the laws is I don't even think there are words, and I have to write math,
Right.
and I have to translate them into math. What does it mean to
What does harm mean?
obey?
It's not math, but
obey what, right? Because we just talked about how you try to say what you want, but you don't always get it right, and you want these machines to do what you want, not necessarily exactly what you literally. So you don't want them to take you literally. You want to take what you say and interpret it in context. And that's what we do with the specified words. We don't take them literally anymore from the designer. Not we as a community, we as some members of my group, we and some of our collaborators like Rabbi and Sir Russell, we sort of say, okay, the designer specified this thing, but I'm gonna interpret it not as this is the word function that I shall always optimize, always and forever, but as this is good evidence about what the person wants, and I should interpret that evidence in the context of these situations that it was specified for. Because ultimately, that's what the designers thought about that. So they had in mind. And really, them specifying the reward function that works for me in all these situations is really kind of telling me that whatever behavior that incentivizes must be good with respect to the thing that I should actually be optimizing for. And so now the robot kind of has uncertainty about what it is that it should be, what its reward function is. And then there's all these additional signals we've been finding that it can kind of continually learn from and adapt its understanding of what people want. Every time the person corrects it, maybe they demonstrate, maybe they stop, hopefully not, right? One really really crazy one is the environment itself. Like our world, it's not, you observe our world and the state of it, and it's not that you're seeing behavior and you're saying, oh, people are making decisions that are rational, blah, blah, blah. But our world is something that we've been acting with according to our preferences. So I have this example where, like, if I walk to my room and my shoes are laid down on the floor, kind of in a line, right? It took effort to do that. So even though the robot doesn't see me doing this, actually aligning the shoes, it should still be able to figure out that I want the shoes on. Because there's no way for them to have magically, instantiated themselves in that way. Someone must have actually taken the time to do that. So it must be important.
So the environment actually tells the environment
Leaks information.
Leaks information. The environment is the way it is because humans somehow manipulated it. So you have to kind of reverse engineer the narrative that happened to create the environment it is, and that leaks the preference information.
You have to be careful, right? Because people don't have the bandwidth to do everything. So just because my house is messy doesn't mean that I wanted to be messy, right? But that just I didn't put the effort into that. I put the effort into something else. So the robot should figure out, well, that's my house is more important, but it doesn't mean that the house is messy and stuff. So it's a little subtle, but when you really think of it, the state itself is kind of like a choice that people implicitly made about how they want their world.
What book or books, technical fiction, philosophical, had when you look back, had a big impact, maybe was a turning point, was inspiring in some way? Maybe we're talking about some book that I might want to read, or maybe it's a book that you recommend to others to read, or maybe those would be two different recommendations that of books that could be useful for people on their journey.
When I was this is kind of a personal story, when I was in 12th grade, I got my hands on a PDF copy in Romania of Russell Norman's AI Modern Approach. I didn't know anything about AI at that point. I had watched the movie The Matrix. That was my exposure. And so I started going through this thing. And you were asking me, what are it's math and its algorithm was interesting. It was so captivating. This notion that you could just have a goal and figure out your way through a kind of a messy, complicated situation. So what sequence of decisions you should make autonomously to achieve that goal. That was so cool. I'm biased, but that's a cool book.
Yeah,
to look at.
You can convert the goal of the process of intelligence and mechanize it. I had the same experience. I was really interested in psychiatry and trying to understand human behavior. And then AI approach is like, wait, you can just reduce it all to.
You can write that about human behavior, right? Yeah. So and I think that stuck with me because a lot of what we do in my lab is write math about human behavior, combine it with data and learning, put it all together, give it to robots to plan with, and hope that instead of writing rules for the robots, writing heuristics, designing behavior, they can actually autonomously come up with the right thing to do around people. That's kind of that's our signature move. So we wrote some math, and then instead of kind of handcrafting this and that, robots figured stuff out, and isn't that cool? And I think that is the same enthusiasm that I got from the robot figured out how to reach that goal in that graph. Isn't that cool?
So, I apologize for the romanticized question, but if a doctor gave you 5 years to live, sort of emphasizing the finiteness of our existence, what would you try to accomplish?
It's like my biggest nightmare, by the way.
I'm playing
really
with
like
whales. I'm playing with whales because they have a dragon on their flag.
Dying.
I call it
I'm sorry, going on there for a second. Do
are about to
you
destroy culture.
meditate or ponder on your mortality or our human effect this thing ends? It seems to be a fundamental feature. Do you think of it as a feature or a bug? Is it you said you don't like the idea of dying, but if I were to give you a choice choice of living forever. Like, you're not allowed to die.
Yeah, now I'll say that I want to live forever, but I watched this show. It's very still called The Good Place, and they reflect a lot on this. And
Yeah, look at your guys.
moral of the story is that you have to make the afterlife be finite too, because otherwise people just it's like Wally. It's like
Whatever.
whatever. So I think the finiteness helps, but
You have
yeah,
a really
it's
good
just
chance.
I'm not a
Get it
religious
to one of your
person.
guys.
I don't think that there's something
Open
after,
goal.
and so I think it just ends and you stop existing. And I really like existing. It's such a great privilege to exist that yeah, it's just I think that's
So, yeah,
the scary part.
I still think that we like existing so much because it ends.
Mm-hmm.
That's so sad.
The dragon attack, baby.
It's so sad to me every time. Like, I find almost everything about this life beautiful. Like, the silliest, most mundane things is just beautiful. And I think I'm cognizant of the fact that I find it beautiful because like it, and it's so. I don't know. I don't know how to feel about that. I also feel like there's a lesson in it from robotics and AI that this is not like the finiteness of things seems to be a fundamental nature of human existence. I think some people sort of accuse me of just being Russian and melancholic and romantic or something, but that seems the fundamental nature of our existence that should be incorporated in our reward functions. But anyway, if you were, speaking of reward functions, if you only had 5 years, what would you try to accomplish?
This is the thing. I'm thinking about this question and have a pretty joyous moment because I don't know that I would change much.
Oh, that's a,
I'm more. I'm. You know, I'm trying to make some contributions to how we understand human AI interaction. I don't think I would change that. Maybe I'll take. You know, I take one trip to the Caribbean or something. But I try to settle down already from time to time. So yeah, I mean, I try to do the things that bring me joy, and thinking about these things bring me joy. Is the Mary Kondo thing, you know, don't do stuff that doesn't spark joy. For the most part, I do things that spark joy. Maybe I'll do like less service as a department or something. Like that card. I'm not dealing with admissions anymore. But no, I mean, I think I have amazing colleagues and amazing students and amazing family and friends, and kind of spending time and some balance with all of them is what I do, and that's what I'm doing already. So I don't know that I would really change it.
so, on the spirit of positiveness, what small act of kindness pops to mind or you once showed you will never forget?
When I was in high school, my friends, my classmates, did some tutoring. We were gearing up for our baccalaureate exam, and they did some tutoring on well, some on math, some on whatever. I was comfortable enough with some of those subjects, but physics was something that I hadn't focused on in a while. So they were all working with this teacher. And I started working with that. Her name is Nicole Bigman, and she was the one who kind of opened up this whole world for me, because she sort of told me that I should take the SATs and apply to go to college abroad and do better on my English and all of that. And when it came to, well, financially I couldn't, my parents couldn't really afford to do all these things, she started tutoring me for free. And on top of that, sitting down with me to kind of train me for SATs and all that jazz that she had experience with.
Wow, good. And that obviously that's taken to here today. Also, one of the world experts in robotics. It's funny, those little.
Yeah, people do these small or
for no reason, really.
acts of kindness.
Just out of karma.
Wanting to support someone.
Yeah. So we talk a ton about reward functions. We talk about the most ridiculous big question. What is the meaning of life? What's the reward function of what you humans operate? Like, what maybe to your life, maybe broader to human life in general, what do you think
No, if you score in the first half, it's a penalty.
What gives life fulfillment, purpose,
The other
happiness?
person gets to go.
You can't even ask that question with a straight face. That's how ridiculous.
Yeah, but there's a way you could just
So-
always score on the first try.
Right, right.
So I was in a planetarium once, and they show you the thing where they zoom out, and it's called like you're a speck of dust kind of thing. I think I was conceptualizing. They were kind of, what are humans? We're just on this little planet, whatever. It doesn't matter much in the grand scheme of things. And then my mind got really blown because they talked about this multiverse theory where they kind of zoomed out and were like, this is our universe. And then like there's a bazillion other ones and it's just they pop in and out of existence. So like our whole thing that we can't even fathom how big it is was like a blink that went in and out. And at that point I was like, okay, I'm done. There's no meaning. Clearly what we should be doing is to try to impact whatever local thing we can impact, our communities, leave a little bit behind there, our friends, our family, our local communities, and just try to be there for other humans. Because everything beyond that seems ridiculous.
I mean, are you, like, how do you make sense of these multiverses? Like, are you inspired by the immensity of it? Do you is there, is it amazing to you, or is it almost paralyzing in mystery?
It's frustrating. I'm frustrated by my inability to comprehend. It just feels very frustrating. So there's some stuff that we should time, blah blah blah, that we should really be understanding. And I definitely don't understand it, but the amazing physicists of the world have a much better understanding than me. But it's just epsilon in the grand scheme of things. So it's very frustrating. It's frustrating because like our brains don't have some fundamental capacity yet. Well, yet or ever, I don't know. But
well, this one of the dreams of artificial intelligence is to create systems that will expand our cognitive capacity in order to understand the theory of everything, with the physics, and understand what the heck these multiverses are. So I think there's no better way to end it than talking about the meaning of life and the fundamental nature of the universe and the multiverse. So, okay, it's a huge honor. One of my favorite conversations I've had. I really appreciate your time. Thank you for coming.
Thank you for coming. Come back again.
Thanks for listening to this conversation with Anka Jugan. Thank you to our presenting sponsor, Cash App. Please consider supporting the podcast by downloading Cash App. Let's podcast. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcasts, or on Patreon, or simply connect with me on Twitter at Lex Freewood. And now, let me leave you with some words from Isaac Asimov. Your assumptions are your windows in the world. Scrub them off every once in a while, and the light will come. Thank you for listening. Hope to see you next time.
One.
Following is a conversation with Simon Sinek, author of several books, including Start With Why, Leaders Eat Last, and his latest, The Infinite Game. He's one of the best communicators of what it takes to be a good leader, to inspire, to build businesses that solve big, difficult challenges. This is the Artificial Intelligence Podcast. If you enjoy it, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support it on Patreon, simply connect with me on Twitter at Lex Friedman, spelled Fridman. As usual, I'll do 1 or 2 minutes of ads now, and never any ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. Quick summary of the ads. 2 sponsors, Cash App and Masterclass. Please consider supporting the podcast by downloading Cash App and using code LEXPODCAST, and signing up to Masterclass at masterclass.com/flex. This show is presented by Cash App, the #1 finance app in the App Store. When you get it, use code LEXPODCAST. Cash App lets you send money to friends, buy Bitcoin, and invest in the stock market for as little as $1. Since Cash App allows you to buy Bitcoin, let me mention that cryptocurrency in the context of the history of money is fascinating. I recommend A Cent of Money as a great book on this history. Debits and credits on ledgers started around 30,000 years ago. The US dollar created over 200 years ago. Bitcoin, the first decentralized cryptocurrency, released just over 10 years ago. So given that history, cryptocurrency is still very much in its early days of development, but is still aiming to, and just might, redefine the nature of money. So again, you get Cash App from the App Store or Google Play, and use the Lex Podcast, you get $10. Cash App will also donate $10 to FIRST, an organization that is helping to advance robotics and STEM education for young people around the world. This show is sponsored by Masterclass. Sign up at masterclass.com/Lex to get a discount to support this podcast. When I first heard about Masterclass, I honestly thought it was too good to be true. For $180 a year, you get an all-access pass to watch courses from experts at the top of their field. To list some of my favorites, Chris Hadfield on space exploration, Neil deGrasse Tyson on scientific thinking and communication, Rabbi, the creator of City City, Sims and game design, of that game, Jane Goodall on conservation, Carlos Santana, one of my favorite guitarists on guitar, Gary Kasparov on chess, obviously I'm Russian, I love Gary, Daniel Negreanu on poker, one of my favorite poker players, also Phil Ivey, gives a course as well, and many, many more. Chris Hadfield explaining how rockets work and the experience of being launched into space alone is worth the money. By way of advice, for me, the key is not to be overwhelmed by the abundance of choice. Pick 3 courses you want to complete, watch each all the way through from start to finish. It's not that long, but it's an experience that will stick with you for a long time, I promise. It's easily worth the money. Watch it on basically any device. Once again, sign up at masterclass.com/Lex to get a discount to support this podcast. Now, here's my conversation with Simon. In the Infinite Game, your most recent book, you described the finite game and the infinite game. So from my perspective on artificial intelligence and game theory in general, I'm a huge fan of finite games from the broad philosophical sense is something that in the robotics artificial intelligence space we know how to deal with. And then you describe the infinite game, which has no exact static rules, has no well-defined static objective. The players are known, unknown, they change. There's a dynamic element. So this is something that applies to business, politics, life itself. So can you try to articulate the objective function here of the infinite game, or in the cliche, broad philosophical sense, what is the
Start with softball.
easy question first?
So Jane Hart's philosopher originally articulated this concept of finite game. And when I learned about it, it really challenged my view of how the world works, right? Because I think we all think about winning and being the best and being number one. But if you think about it, only in a finite game can that exist. A game that has fixed rules, agreed upon objectives, and known players like football or baseball. There's always a beginning, middle, and end. If there's a winner, there has to be a loser. Infinite games, as Christ described it, as you said, known and unknown players, which means anyone can win. It has changeable rules, which means you can play however you want. And the objective is to perpetuate the game, stay in the game as long as possible. In other words, there's no such thing as being number one or winning in a game that has no finish line. And what I learned is that when we try to win in a game that has no finish line, we try to be the best in a game that has no agreed upon objectives or agreed upon metrics or time frames. There's a few consistent and predictable outcomes: the decline of trust, the decline of cooperation, the decline of innovation. And
find this fascinating because so many of the ways that we run most organizations are the finite mindset.
They're trying to reduce the beautiful, complex thing that is life or politics and business into something very narrow. And in that process, of the reductionist process, you lose something fundamental that makes the whole thing work in the long term. So, returning, I'm not going to let you off the hook easy. What is the meaning of life? So, what is the objective function that is worthwhile to pursue?
Well, if you think about a tombstone, right? They have the date we were born and the date we die. But really, it's what we do with the gap in between. There's a poem called The Dash. It's the dash that matters. It's what we do between the time we're born and the time we die that gives our life meaning. And if we live our lives with a finite mindset, which means to accumulate more power or money than anybody else, to outdo everyone else, to be number one, to be the best, we don't take any of us with us. We don't take any of it with us. We just die. The people who get remembered, the way we want to be remembered is what kind of people we were, right? Devoted mother, loving father, what kind of person we were to other people. Jack Welch just died recently, and the Washington Post, when it wrote the headline for his obit, it wrote, "He pleased Wall Street and distressed employees." And that's his legacy. A finite player who is obsessed with winning, who leaves behind a legacy of short-term gains for a few and distress for many. That's his legacy. And every single one of us gets the choice, the kind of legacy we want to have. Do we want to be remembered for our contributions or our detractions? To live with a finite mindset, to live a career with a finite mindset, to be number one, be the best, be the most famous, live a life like Jack Welch, to live a life of service, to see those around us rise, to contribute to our communities, to our organizations, to leave them in better shape than we found them. That's the kind of legacy most of us would like to have.
So day to day, when you think about what is the fundamental goals, dreams, motivations of an infinite game of seeing your life, your career as an infinite game, what does that look like? I mean, I guess I'm sort of trying to stick on this personal ego, personal drive, the thing that the fire, the reason we want to wake up in the morning, and the reason we can't go to bed because we're so excited.
Yeah.
What is that?
So for me, it's about having a just cause. It's about a vision that's bigger than me. That my work gets to contribute to something larger than myself. That's what drives me every day. I wake up every morning with a vision of a world that does not yet exist, a world in which the vast majority of people wake up every single morning inspired, feel safe at work, and return home fulfilled at the end of the day. It's not the world we live in. And so that we still have work to do is the thing that drives me. I know what my underlying values are. I wake up to inspire people to do the things that inspire them. These are my go-to, my touch point that inspire me to keep working. I think of a career like an iceberg, a vision for something. You're the only one who can see the iceberg underneath the ocean. But if you start working at it, a little bit shows up. And now a few other people can see what you imagine. Like, oh, right. Yeah. No, I want to build that as well. And if you have a lot of success, then you have a lot of icebergs. People can see this book and say, you've accomplished so much. But what I see is all the work still yet to be done. I still see.
And so the growth, you talk about momentum. So the spurt is what drives you.
Well, it necessarily is incremental. It's the realization of realizing the iceberg, bringing more input from the unknown, more division from the imagination to reality.
And in this world, I have I see myself a little bit as the main character from The Idiot by Dostoevsky, who's also kind of seen by society as a fool because he was optimistic. So, can you maybe articulate where that sense of optimism comes from, and maybe also try to articulate your vision of the future where people are inspired, where optimism drives us? It's easy to forget that when you look at social media and so on, where toxicity and negativity can often get more likes, that optimism has a sort of a beauty to it. I do hope it's out there So what can you try to articulate that vision?
Yeah. So, I mean, for me, optimism and being an optimist is just seeing the silver lining in every cloud. Even in tragedy, it brings people together. And the question is, can we see that? Can you see the beauty that is in everything? I don't think optimism is foolishness. I don't think optimism is blindness. Though it probably involves some naivete, the belief that things will get better, the belief that we tend towards the good, even in times of struggle or bad. But, you know, you can't sustain war, but you can sustain peace. I think things that are stable are more sustainable. Things that are optimistic are more sustainable than things that are chaotic.
Um, you see people as fundamentally good. I mean, some people may disagree that you can sustain peace, you can't sustain war.
I mean, we don't have to. I think war is costly. It involves life and money, and peace does not involve those things. It requires work. I'm not saying it doesn't require work, but it doesn't drain resources. I think it's important.
You know, the people that would say that we will always have war, I just talked to the historian of Stalin, is, let's say that conflict and the desire for power and conflict is central to human nature. Right? It's something, but something in your words also, perhaps it's the naive aspect that I also share, is that you have an optimism that people are fundamentally good and
An idealist, and I think idealism is good. I'm not a fool to believe that the ideals that I imagine can come true. Of course, they'll never be world peace, but shouldn't we die trying? I think that's the whole point. That's the whole point of vision. Vision should be idealistic, and it should be, all practical purposes, impossible. But that doesn't mean we shouldn't try. It's the milestones that we reach that take us closer to that ideal, that make us feel that our life and our work have meaning and we're contributing to something bigger than ourselves. We just because it's impossible doesn't mean we shouldn't try. As I said, we're still moving the ball down the field. We're still making progress. Things are still getting better, even if we never get to that ideal state. So I think idealism is a good thing.
The word infinite game. One of the beautiful and tragic aspects of life, human life at least from the biological perspective, is that it ends. So sadly, something finite. It's tragic to some people, or is it ends?
I think some people believe that it ends on the day you die. Some people think it continues.
There's a lot of different ways to think what continues on in your life. But let me drag it back to the personal, which is how do you think about your own mortality? Are you afraid of death? How do you think about your own death?
I definitely haven't accomplished everything I want to contribute to. I would like more time on this earth to keep working towards that vision.
Do you think about the fact that it ends for you? Are you cognizant of
course, I'm cognizant of it. I mean, that we all. I don't dwell on it. I'm aware of it. I know that my life is finite, and I know that I have a certain amount of time left on this planet, and I'd like to make that time be valuable.
Some people would think that ideas kind of allow you to have a certain kind of immortality. Maybe to look on this kind of question. So first, to push back on you said that everyone is cognizant of their mortality. There's a guy named Ernest Becker who would disagree. That he basically say that most of human cognition is created by us trying to create an illusion and try to hide the fact from ourselves, the fact that we're going to die. We try to think that it's all going to go on forever.
But the fact that we know that it doesn't.
Yes, but this mix of denial. I think the book is called Denial of Death.
Yeah.
It's this constant denial that we're away from. In fact, some would argue that the inspiration, the incredible ideas you put out there, your TED Talk has been seen by millions and millions of people, right? It's just you trying to desperately fight the fact that you are biologically mortal. Your creative genius comes from the fact that you're trying to create ideas that live on long past you.
Well, it's very nice of you. I mean, I would like my ideas to live on beyond me, because I think that is a good test that those ideas have value in the lives of others. I think that's a good test that others would continue to talk about or share the ideas long after I'm gone. I think is perhaps the greatest compliment one can get for one's own work. That's very, but I don't think it's my awareness of my mortality that drives me to do it. It's my desire to contribute that drives me to do it.
It's the optimist vision. It's the pleasure and fulfillment you get from writing others. It's pure as that. Let me ask. Listen, I'm rushing. I'm trying to get
You're good. You're good.
Get you into these dark areas.
I've enjoyed it.
Is the ego tied up into it somehow? So your name is extremely well known. If your name wasn't attached to it, do you think you would act differently?
I mean, for years I hated that my name was attached to it. I had a rule for years that I wouldn't have my face on the cover, the front page of the website. I had a fight with the publisher because I didn't want my name big on the book. I wanted it tiny on the book because I kept telling them it's not about me, it's about the ideas. They wouldn't put my name at the top of my book. I refused. None of my books have my names at the top because I won't let them. They would like very much to put my name at the top of the book, but the idea has to be bigger than me. I'm not bigger than the idea.
It's beautifully put. Do you think ego?
But I also am aware that I'm become recognized as the messenger. And even though I still think the message is bigger than me, I recognize that I have a responsibility as the messenger. And whether I like it or not is irrelevant. I accept the responsibility. I'm happy to do it.
I'm not sure how to phrase this, but there's a large part of the culture right now that emphasizes all the things that nobody disagrees with, which is health, sleep, diet, relaxation, meditation, are really important. And there's no, it's like you can't really argue against that. In fact, people
Less sleep.
just I'm joking. Yes, well, that's the thing. I often speak to the fact that passion and love for what you're doing, and towards hard work, especially in the engineering fields, are more important to prioritize than sleep. Even though sleep is really important, your mind should be obsessed with the hard work, with the passion, and so on. And then I get some pushback, of course, from people. What do you make sense of that? Is that just me, the crazy Russian engineer, really pushing hard work?
Probably.
What do you?
I think that's a short-term strategy. I think if you sacrifice your health for work, at some point it catches up with you. And at some point it's like going, you get sick. Your body will shut down for you if you refuse to take care of yourself. You get sick. That's what happens. Sometimes, more severe illness than something that just slips you down. So I think getting sleep. I mean, there's been studies on this. That, executives, for example, who get a full night's sleep and stop at a reasonable hour actually accomplish more, are more productive than people who work midnight oil because their brains are working better because they're well rested. So, working hard, yes, but we want to work smart. I think that giving our minds and our bodies rest makes us more efficient. I think just driving is a short-term strategy.
So to push back on that a little bit, so the annoying thing is you're like 100% right in terms of science, right? But the thing is, it's because you're 100% right. That weak part of your mind uses that fact against you. Like what? So I get all kinds of. My mind comes up with all kinds of excuses to try to convince me that I shouldn't be doing what I'm doing, to rationalize. And so what I have a sense, I think what you said about executives and leaders is absolutely right. But there's the early days of madness and passion. Sure. Then I feel like emphasizing sleep, because thinking about sleep is giving yourself a way out of the fact that those early days, especially, can be suffering.
It's not sustainable. It's not sustainable. Sure, if you're investing all that energy in something at the beginning to get it up and running, then at some point you're going to have to slow down, or your body will slow down for you. you can choose, your body can choose. I mean,
So okay, so you don't think, from my perspective, it feels like people have gotten a little bit soft. You're saying no.
no, I think that there seems evidence that harder and later have taken a back seat. In I think we have to be careful with broad generalizations, but I think if you go into the workplace, there are people who complain that more people now than before look at their watches and say, "Oh, it's 5 o'clock, goodbye." Right now, is that a problem? You're saying that people giving themselves excuses and people who don't work hard, or is it the organizations aren't giving them something to believe in, something to be passionate about? You can't manufacture passion. You can't just tell someone be passionate. That's not how it works. Passion is an output, not an input. Like if I believe in something and I want to contribute all that energy to do it, we call that passion. Working hard for something we love is passion. Working hard for something we don't care about is called stress. So we're working hard either way. So I think the organizations, there's some accountability, and our leaders, there's some accountability, which is if they're not offering a sense of purpose, if they're not offering us a sense of cause, if they're not telling us that our work is worth more than simply the money it makes, then yeah, I'm going to become a private platform because I don't really care about making you money. Remember, we live in a world right now where a lot of people, rather a few people, are getting rich from the hard work of others. And so I think when people look up and say, well, why would I do that? Just if you're not going to look after me, and then you're going to lay me off at the end of the year because you missed your arbitrary projection, you're going to lay me off because you missed your arbitrary projection, then why would I offer my hard work and loyalty to you? So I don't think we can immediately blame people for going soft. I think we can blame leaders for their inability or failure to offer their people something bigger than making a product or making money.
Yeah, that's brilliant. And you start with why, you last books, you kind of you basically talk about what it takes to be a good leader, and so some of the blame should go on the leader, but how much of it is on finding your passion? How much is it on the individual and allowing yourself to pursue that passion, pushing yourself to your limits to really take concrete steps along your path towards that passion?
Yeah, there's mutual responsibility. There's mutual accountability. We're responsible as individuals to find the organizations and find the leaders that inspire us. And organizations are responsible for maintaining that flame and giving people who believe what they believed, a chance to contribute.
So to linger on that, have you by chance seen the movie Whiplash?
Yes.
Again, maybe I'm romanticizing something. Again,
It's the Russian Indian.
it's the Rush.
Yeah, the Russians love something.
But so for people who haven't seen, it's the movie Whiplash as a drum instructor that pushes the drum musician to his limits to bring out the best in him. And there's a toxic nature to it, and there's suffering in it. Like you worked with a lot of great leaders, a lot of great individuals. So is that toxic relationship as toxic as it appears in the movie, or is that fundamental? I've seen that relationship, especially in the past with Olympic athletes, especially in the athletics, extreme performers seem to do wonders. It does wonders for me. There's some of them are my best relationships. Now I'm not a representative, but some of my best relationships, mentee and mentor, have been toxic from an external perspective. What do you make of that movie? What do you think of that relationship?
But it's not my favorite movie.
Okay. So you don't think that's a healthy? You don't think that kind of relationship is a great example of a great leader?
It's a short-term strategy. I mean, look, being hard on someone is not the same as toxicity. If you go to the Marine Corps, a drill instructor will be very hard on their Marines, but still, even on the last day of boot camp, they'll take their hat off and they'll become human. But of all the drill instructors, the 3 or 4 main drill instructors assigned to a group of recruits, the one that they all want the respect of is the one that's the hardest on them. That's true. And you hear, there's plenty of stories of people who want to earn the respect of a hard parent or a hard teacher. But fundamentally, that parent, that teacher, that drill instructor has to believe in that person, has to see potential in them. it's not a formula, which is if I'm hard on people, they'll do well. Which is there has to still be love. It has to be done with absolute love, and it has to be done responsibly. I mean, some people can take a little more pressure than others. It's not. I think it's irresponsible to think of it as a formula that if I'm just toxic at people, they will do well. It depends on their personalities. First of all, it works for some, but not all. And second of all, it can't be done willy-nilly. It has to still be done with care and love, uh, uh, and sometimes you can get equal or better results without all of the toxicity.
So one of the, I guess, toxicity on my part was a really bad word to use. But if we talk about what makes a good leader, and just look at an example in particular, looking at Elon Musk, he's known to push people to their limits in a way that I think really challenges people in a way they've never been challenged before, to do the impossible, sure. But it can really break people.
Jobs is hard, and Amazon is hard. But the thing that's important is none of them lie about it. People ask me about Amazon all the time. Like, Jeff Bezos never lied about it. Even the ones who like Amazon don't last more than a couple of years before they burn out. But when we're honest about the culture, then it gives people the opportunity who like to work in that kind of culture to choose to work in that kind of culture, as opposed to pretending and saying, "Oh no, this is all, it's all lovey-lovey here," and then you show up and it's the furthest thing from it. So, I mean, I think the reputation of putting a lot of pressure on people to, Jobs was not an easy man to work for. He pushed people, but everyone who worked there was given the space to create and do things that they would not be able to do anywhere else. And work for level, work anywhere else. And Jobs didn't have all the answers. He pushed his people to come up with answers. He wasn't just looking for people to execute his ideas. And people did. People accomplished more than they thought they were capable of, which was wonderful.
You're talking about the infinite game and not thinking about too short term, and yet you see some of the most brilliant people in the world being pushed by Elon Musk to accomplish some of the most incredible things. When we're talking about autopilot one, we're talking about some of the hardware engineering, and they do some of the best work of their life and then leave. How do you balance that in terms of what it takes to be a good leader, what it takes to accomplish great things in your life?
Yeah. So I think there's a difference between someone who can get a lot out of people in the short term and building an organization that can sustain beyond any individual. There's a difference.
When you say beyond any individual, you mean beyond like if the leader dies.
Right. Like could Tesla continue to do what it's doing without Elon Musk?
And you're perhaps implying just a very interesting question that it cannot.
I don't know. The argument you're making of this person who pushes everyone, arguably is not a repeatable model, right? Is Apple the same without Steve Jobs, or is it slowly moving in a different direction? Or has he established something that could be resurrected with the right leader?
That was his dream, I think, is to have or to build an organization that lives on beyond him. At least I remember.
I think that's what a lot of leaders desire, which is to create something that was bigger than them. Most businesses, most entrepreneurial ventures could not pass the school bus test, which is if the founder was hit by a school bus, would everyone continue the business without them, or would they all just go find jobs? And the vast majority of companies failed that test, especially in the entrepreneurial world. And if you take the inspired visionary leader away, all the collapse. So is that a business, or is that just a force of personality? And a lot of entrepreneurs, face that reality, which is they have to be in every meeting, make every decision, come up with every idea, because if they don't, who will? And the question is, well, what have you done to build your bench? It's not, sometimes it's ego, the belief that only I can. Sometimes it's just things did so well for so long that just forgot. And sometimes it's a failure to build the training programs or hire the right people that could replace you, who are maybe smarter and better. And browbeating people is only one strategy. I don't think it's necessarily the only strategy, nor is it always the best strategy. I think people could choose the cultures they want to work in. So this is why I think companies should be honest about the kind of culture that they've created. I heard a story about Apple where somebody came in for a big company, had accomplished a lot, and his ego was very large. He was going on about how he did this and he did that and he did this and he did that. And somebody from Apple said, "We don't care what you've done. The question is, what are you going to do?" And that's for somebody who wants to be pushed, that's the place you go, because you choose to be pushed. Now, we all want to be pushed to some degree. Anybody who wants to accomplish anything in this world wants to be pushed to some degree, whether it's through self-pressure or external pressure or public pressure, whatever it is. But I think this whole idea of one size fits all is a false narrative of how leadership works. But what all leadership requires is creating an environment in which people can work at their natural best.
Like you have a sense that it's possible to create a business where it lives on beyond you. So if we look at now, if we just look at this current moment, I just recently talked to Jack Dorsey, CEO of Twitter, and he's under a lot of pressure now. I don't know if you're aware of the news that he's being pushed out as potentially as the CEO of Twitter, because he's the CEO already of an incredibly successful company. Plus, he wants to go to Africa to live a few months in Africa to connect with the world that's outside of Silicon Valley. And so there's this idea, well, can Twitter live without Jack? Like you have a general, as a student of great leadership, you have a general sense that it's possible.
Yeah, of course it's possible. I mean, what Bill Gates built with Microsoft may not have survived Steve Ballmer if the company weren't so rich. But Satya Nadella is putting it back on track again. It's become a visionary company again. It's attracting great talent again. That's for a period where you couldn't get the best talent, and the best talent was leaving. Now people want to work for Microsoft again. Well, that's not because of pressure. Ballmer put more pressure on people, mainly to hit numbers, than anything else. That didn't work, right? And so the question is what kind of pressure? Putting up pressure people to hit numbers or hit arbitrary deadlines, or putting on pressure on people because we believe that they can do better work. And the work that we're trying to do is to advance a vision that's bigger than all of us. And if you're going to put pressure on people, it better be for the right reason. Like if you're going to put pressure on me, it better be for a worthwhile reason. If it's just to hit a goal, if it's just to hit some arbitrary date or some arbitrary number or make a stock price hit some target, you can keep it. I'm out of here. But if you want to put pressure on me because we are brothers and sisters in arms, working to advance a cause bigger than ourselves, that we believe whatever we're going to build will significantly contribute to the greater good of society, then go ahead, I'll take the pressure. And if you look at the Apples, if you look at the Elon Musks, the jobs of the Elon Musk, they fundamentally believe that what they were doing would improve society, and it was for the good of humankind. And so the pressure, in other words, what they were doing was more important, more valuable than any individual. And so the pressure they put on people served a greater good. And so we looked to the left and looked to the right to each other and said, we're in this together. We accept this. We want this. But if it's just pressure to hit a number or make the widget move a little faster, that's soul sucking. That's not passion. That's stress. And I think a lot of leaders confuse that making people work hard is not what makes them passion. Giving them something to believe in and work on is what drives passion.
We have that turning up the pressure brings people together, drives them
if
further.
Done the right way.
Speaking of pressure, I'm going to give you 90 seconds to answer the last question, which is if I tomorrow was made to live, talk mortality, sunrise, sunset, can you tell me, can you take me through the day? What do you think that day would involve? You can't spend it with your family.
Oh, I probably want to fill all of my senses with things that excite my senses. I want to look at beautiful art. I want to listen to beautiful music. I want to taste incredible food. I want to smell amazing tastes. I want to touch, you know, something that, something beautiful to touch. I want all of my senses to just be consumed with the thing that I find beautiful.
And you talked about this idea of we don't do it often these days, of just listening to music, turning off all the devices, and actually taking in and listening to music. So, as an addendum, if we were to talk about music, what song would you be blasting in this last day you're alive? Is it Led Zeppelin? What would we have that?
No. There's probably going to be a Beatles song in there. There'll definitely be some Beethoven in there.
The classics. Okay. Thank you so much for talking to us. Thank you for making time for it. Under pressure, we made it happen.
Yeah, it was great.
Thanks for listening to this conversation with Simon Sinek. Thank you to our sponsors, Cash App and Masterclass. Please consider supporting the podcast by downloading Cash App and using code LEX Podcast and signing up to Masterclass at masterclass.com/LEX. If you enjoy this podcast, subscribe on YouTube, review it with 5 stars on Apple Podcasts, support on Patreon, or simply connect with me on Twitter at Lex. And now, let me leave you with some words from Simon Sinek. There are only 2 ways to influence human behavior. You can manipulate it, or you can inspire it. Thank you for listening. I hope to see you next time. Following is a conversation with Nick Bostrom, a philosopher at the University of Oxford and the director of the Future of Humanity Institute. He has worked on fascinating and important ideas in existential risk, simulation hypothesis, human enhancement, ethics, and the risks of superintelligent AI systems, including in his book, Superintelligence. I can see talking to Nick multiple times in this podcast, many hours this time. He has done some incredible work in artificial intelligence, technology space, science, and really philosophy in general. But we have to start somewhere. This conversation was recorded before the outbreak of the coronavirus pandemic, but both Nick and I'm sure, will have a lot to say about next time we speak. And perhaps that is for the best, because the deepest lessons we learned only in retrospect, when the storm has passed. I do recommend you read many of his papers on the topic of existential risk, including the technical report titled Global Catastrophic Risks Survey that he co-authored with Anders Sandberg. For everyone feeling the medical, psychological, and financial burden of this crisis, I'm sending love your way. Stay strong. We're in this together. We'll beat this thing. This is the Artificial Intelligence Podcast. You can subscribe on YouTube, review it with 5 stars on Apple Podcasts, on Patreon, simply connect me on Lex spelled FRIDMAS. As usual, I'll do 1 or 2 minutes of ads now, never any ads in the middle that can break the flow of the conversation. I hope that works for you. It doesn't hurt the listening experience. This show is presented by Cash App, the #1 finance app in the App Store. When you get it, use code LEX Podcast. Cash App lets you send money to friends, buy Bitcoin, and invest in the stock market in as little as $1. As Cash App does fractional share trading, let me mention that the order execution algorithm that works behind the scenes to create the abstraction of fractional orders is an algorithmic marvel. The big props to Cash App engineers for solving a hard problem that in the end provides an easy interface that takes a step up to the next layer of abstraction over the stock market, making trading more accessible for new investors and diversification easier. So again, if you get Cash App from the App Store and Google Play and use the code LEX Podcast, you get $10. Cash App will also donate $10 to FIRST, an organization that is helping to advance robotics and STEM education to young people around the world. And now, here's my conversation with Nick Bostrom. at the risk of asking the Beatles to play yesterday or the Rolling Stones to play satisfaction, let me ask you the basics. What is the simulation hypothesis?
That we are living in a computer simulation.
What is a simulation? How are we supposed to think about that?
Well, so the hypothesis is meant to be understood in a literal sense, not that we can kind of metaphorically view the universe as an information processing physical system, but that there is some advanced civilization that built a lot of computers, and that what we experience is an effect of what's going on inside one of those computers, so that the world around us, our own brains, everything we see and perceive and think and feel, so would exist because this computer is running certain programs.
Do you think that this computer has something similar to the computers of today, in these deterministic sort of Turing machine type things? Is that what we're supposed to imagine, or we're supposed to think of something more like a quantum mechanical system, something much bigger, something much more complicated, something much more mysterious from our current perspective?
So the ones we have today would be quite a bit bigger, certainly. We need more memory and more processing power. I don't think anything else would be required. Now, it might well be that they do have, maybe they have quantum computers and other things that would give them even more. It's kind of plausible, but I don't think it's a necessary assumption in order to get to the conclusion that a technologically mature civilization would be able to create these kinds of computer simulations with conscious beings inside them.
And do you think the simulation hypothesis is an idea that's most useful in philosophy, computer science, physics? So where do you see it having valuable kind of starting point in terms of thought experiment?
It's useful, I guess it's more informative and interesting and maybe important. But it's not designed to be useful for something else.
Okay, interesting, sure. But is it philosophically interesting, or is there some kind of implications for computer science and physics?
I think not so much for computer science or physical science. Certainly it could be of in philosophy also, to say cosmology or physics, in as much as you're interested in the fundamental building blocks of the world and the rules that govern it. And if we are in a simulation, there is then the possibility that, say, physics at the level where the computer running the simulation could be different from the physics governing phenomena in the simulation. So I think it might be interesting from the view of religion, or just for kind of trying to figure out what the heck is going on. So we mentioned the simulation hypothesis so far. There is also simulation argument, which I tend to make a distinction. So simulation hypothesis, we are living in a computer simulation. Simulation argument is argument that tries to show that one of three propositions is true, one of which is the simulation hypothesis, but there are two alternatives in the original simulation argument, which we can get to.
Yeah, let's go there. By the way, confusing terms.
Yeah.
People will, I think, probably naturally think simulation argument equals simulation hypothesis.
Yeah.
So just terminology-wise, but let's go there. So simulation hypothesis means that we are living in a simulation. Instead of a hypothesis, we're living in a simulation. Simulation argument has these three complete possibilities that cover all possibilities. So
so it's like a disjunction. It says at least one of these three is true, although it doesn't on its own tell us which one. So the first one is that almost all civilizations at our current stage of technological development go extinct before they reach technological maturity. So there is a great filter that makes it so that basically none of the civilizations throughout, maybe vast cosmos will ever get to realize the full potential of technology.
And this could be, theoretically speaking, this could be because most civilizations kill themselves too eagerly or destroy themselves too eagerly, or it may be super difficult to build a simulation. So the span of time.
Theoretically, it could be both. Now, I think it looks like we would technologically be able to get there in a time span that is short compared to, say, the lifetime of planets and other sort of astronomical processes.
The reason is to build simulation is not.
So this is interesting concept, technological maturity. It's kind of an interesting concept to have for other purposes as well. We can see, even based on our current limited understanding, what some lower bound would be on the capabilities that we could realize by just developing technologies that we already see are possible to start. For example, one of my research fellows here, Eric Wexler, back in the 80s, studied molecular manufacturing. That is, you could analyze using theoretical tools, computer modeling, the various molecular structures that we didn't then and still don't today have the ability to fabricate. But you could say that, well, if we could put these atoms together in this way, then the system would be stable and it would, rotate at this speed and have all these computational characteristics. And he also outlined some pathways that would enable us to get to this kind of molecular manufacturing into the fullness of time. You could do other studies we've done. You can look at the speed at which, say, it would be possible to colonize the galaxy if you had mature technology. We have an upper limit, which is the speed of light. We have sort of a lower current limit, which is how fast current rockets go. We know we can go faster than that by just, making them bigger and have more fuel and stuff. But you can then start to describe the technological affordances that would exist once a civilization has had enough time to develop, even at least those technologies we already know are possible. Then maybe they would discover other new physical phenomena as well that we haven't realized that would enable them to do even more. But at least there is this kind of basic set of capabilities.
Interesting on that. How do we jump from molecular manufacturing to deep space exploration to mature technology? Like, what's the connection?
Well, so these would be two examples of technological capability sets that we can have a high degree of confidence are physically possible in our universe, and that a civilization that was about to continue to develop its science and technology would eventually attack.
You can intuit, like, we can kind of see the set of breakthroughs that are likely to happen. You can see, like, what would you call it, the technological set?
With computers, maybe it is just one is we can just imagine bigger computers using exactly the same parts that we have, so it kind of scales it that way, right? But you could also make processors a bit faster if we had this molecular nanotechnology that Eric Wexler described. He characterized a kind of crude computer built with these parts that could perform the million times the human brain while being significantly smaller, the size of a sugar cube. And he made no claim that that's the optimum computing structure. Like, well, you could build faster computers that would be more efficient, but at least you could do that if you had the ability to do things that were computer size. So you can then combine these two. You can have this kind of nanomolecular ability built things atom by atom, then say at this spatial scale that would be attainable through space colonizing technology. You can then start, for example, to characterize a lower bound on the amount of computing power that a technologically mature civilization would have if it could grab resources, planets and so forth, and then use this molecular nanotechnology to optimize them for computing. You get a very, very high lower bound on the amount of compute.
So technologically mature civilization is one that took that piece of technology to its lower bound. What is a technologically mature
Well, okay,
civilization?
so it's a strong concept that we really need for the simulation hypothesis. I just think it's interesting in its own right. So it would be the idea that there's at some stage of technological development where you basically maxed out. So you developed all those general purpose, widely useful technologies that could be developed, or at least kind of come very close to the material, 99.9% there or something. That's an independent question. You can think either that there is such a ceiling, or you might think it just goes, the technology tree just goes on forever.
Where does your sense fall?
I would guess that there is a maximum that you would start to asymptote for.
So new things won't keep springing out. I know a new ceiling.
In terms of basic technological capabilities, I think that there's like a finite set of those that can exist in this universe. Moreover, I mean, I wouldn't be that surprised if we actually reach close to that level fairly shortly after we have, say, machine super intelligence. So I don't think it would take millions of years for a human originating civilization to begin to do this. It's like more likely to happen on historical scale. But that's an independent speculation from the simulation argument. I mean, for the purpose of the simulation argument, it doesn't really matter whether it goes indefinitely far up or whether there's a ceiling, as long as we know we can at least get to a certain level. And then it also doesn't matter whether that's going to happen in 100 years or 5,000 years or 50 million years. Like the time scales really don't make any difference.
Can you look down that a little bit? Like there's a big difference between 100 years and 10 million years.
Yeah.
So it doesn't really not matter, because you just said, does it matter if we jump scales to beyond historical scales? So you describe that. So for the simulation argument, sort of, doesn't it matter that we, if it takes 10 million years, it gives a lot of opportunity to destroy civilization?
Yeah, well, so it would shift around the probabilities between these three alternatives. That is, if we are very, very far away from being able to create these simulations, it's like, say, billions of years into the future, then it's more likely that we will fail ever to get there. More time for, get books they have. So it's similarly for other stations.
So it is important to know how hard it is to build simulation.
In terms of figuring out which of the discounts. But for the simulation argument itself, which is agnostic as to which of these three alternatives is.
Okay.
Like you don't have to sit, like the simulation argument would be true whether or not we thought this could be done in 500 years, so it should take 500 million years.
No, for sure. The simulation argument stands. I mean, I'm sure there might be some people who oppose it, but it doesn't matter. I mean, it's very nice those three cases covered. The fun part is at least not saying what the probabilities are, but kind of thinking about, kind of intuiting, reasoning about what's more likely, what are the kind of things that would make some of the arguments less more. So let's actually, I don't think we went through them. So number one is we destroy ourselves before we ever create something.
Right. So that's kind of sad, but we have to think not just what might destroy us. I mean, so there could be some whatever disasters from meteors slamming the Earth a few years from now that could destroy us, right? But you'd have to postulate, in order for this first system to be true, that almost all civilizations throughout the cosmos also failed to reach technological maturity.
And the underlying assumption there is that there's likely a very large number of other intelligent civilizations.
Well, if there are, that they will virtually all have to succumb in the same way. I mean, that leads off another. I guess there are a lot of little digressions. Just that there is something.
Go there.
So
Go there.
yeah,
Keep dragging us back.
When there are there's a set of basic questions that always come up in conversations with interesting people.
Yeah.
Like the Fermi paradox. Like there's you can almost define whether a person is interesting. Whether at some point the question of the Fermi paradox comes up. But, well, so for what it's worth, it looks to me that the universe is very big. I mean, in fact, according to the most popular current cosmological theory is infinitely big. And so then it would follow pretty trivially that it would contain a lot of other civilizations, in fact, infinitely many. If you have some local stochasticity and infinitely many, it's like, infinitely many lumps of matter, one next to another, there's kind of random stuff in each one, then you're going to get all possible outcomes with probability 1 infinitely repeated. So then certainly there would be a lot of extraterrestrials out there. I mean, even short of that, if the universe is very big, that might be a finite but large number. If we were literally the only one, then if we went extinct, then all of civilizations at our current stage would have gone extinct before becoming technological material. So then it kind of becomes trivially true that a very high fraction of those went extinct. But if we think there are many, I mean, it's interesting because there are certain things that possibly could kill us, like if you look at existential risks, and it might be a different, like the best answer to what would most likely to kill us might be a different answer than the best answer to the question, if there is something that kills almost everyone, what would that be? Because that would have to be some risk factor that was kind of uniform overall possible civilization.
Yeah, so in this, for the sake of this argument, you have to think about not just us, but like every civilization dies out before they create the civilization.
Yeah, or something very close to
Okay, so what's number 2?
Well, so number 2 is the convergence hypothesis. That is that maybe like a lot of these civilizations do make it through to technological maturity, but out of those who do get there, they all lose interest in creating these simulations. So they have the capability of doing it, but they choose not to. Not just a few of them decide not to, but out of a million, maybe not even a single one of them would do it.
And I think when you say lose interest, that sounds like unlikely because it's like they get bored or whatever, but it could be so many possibilities within that. I mean, losing interest could be it could be anything from it being exceptionally difficult to do to fundamentally changing the sort of the fabric of reality if you do it, and ethical concerns, all of